Well, hello there, everybody. Welcome to SkyTour live stream for this July 23rd, 2022. I'm Marc D'Antonio, here as usual with our ever-intrepid Daryl Mason. Hello, Daryl. How are you doing?
Hello, Marc. I'm good. You? Hello, everybody.
I'm doing fine. I'm doing just fine. Things are good right now. We are encouraging the sky to clear for us out there. It's not quite clear. This is the star Antares, all right, and we are using it as just a point of reference right now. And I will maneuver the telescope around as soon as it gets a little bit darker. We're watching the clouds very carefully. We do have clouds and storms in the area. But keep in mind, this is the monsoon season here in Arizona, in Arizona, I should say. So we are going to get some clouds and rain. But right now, we're kind of clear right now. And so I'm taking advantage of that. And we're going to try and look at a couple things down toward the south. The clouds are more toward the northeast and the northeast. And there's some in the southeast we might be concerned with later on. But right now, we should be okay. First thing I want to do is welcome some folks here. I am so happy to see the PG was the first one here. Hello there, Petita. Daisy and Zoe Amethyst are here with Lane. Hi, Lane. How are you? And Robin Curtis. Hi, Robin. I've been talking to Robin lately. I met her in Denver. And maybe Roswell. I think you were in Roswell too, Robin. She was at the conferences, UFO conferences, so we got to talk. And Donald Kunzer is here with us. Hi, Donald. And we have Izabela, of course. Izabela Melamed. She is our star table of contents generator. She's also an amazing artist in her own right. Do check out her site. Izabela, put up your link, please, so people know. You're always so, you never think of that, and I always think of it. But please do that. And we have with us as well, I think I said hello to Lane already, right? I did, yeah. Okay, and Lane says hi to me too. That's very good. Yeah, and Vera Lucia Campos from Brasilia is with us tonight. Tara is here too. Tara is the artist who did our door out in the observatory. It's just a phenomenal piece of artwork. Very humbled by the work she did on that. So show us some love.
Marianne is here too.
And Marianne is here as well. Ronald is here. I didn't get to Marianne's name in the list yet. This guy Daryl keeps showing up in the chat. Who's he? Jeez. Then we have Anahata77. That's Bonnie out in Colorado. In your neck of the woods, Daryl.
Yeah. She's a few hours away.
Yeah, but Colorado's big. So It's good to see you guys. Thank you for joining us early on. We're going to look at a couple things tonight and try to make sure we can see them before we get clouded out, and hopefully we won't. Hello, Cindy Murphy. Good to see you. Marianne, I guess, is here too. I didn't see your name yet. I keep looking. But there she is. There she is. Yeah, and Marianne says, hello, Marc and Daryl, all my wonderful peeps in the chat. Remember the peeps? Those yellow marshmallow things? They were disgusting. I think every peep ever made was made in like 1922, and they just keep recycling them. Right? Those are crazy things. Tim F., what's happening? Nice to see you. Yeah, and Carmen is with us tonight, and Mike Gales. Mike Galea. How you doing? Michael Galea is with us. Good to see you. All right. So that said, here you can see our. That's the red star Antares, and Scorpius the Scorpion. And to see kind of where we are, let's bring up our planetarium. You can see Antares here. The telescope is slightly misaligned, and I'm going to try and correct that now. And there we go. So now the telescope is corrected, and the coordinate system is set for Antares. And right north of here is Comet K2. That's the Panstarrs comet that we talked about. We've seen that. There it is coming up on the screen now. Okay. And it's an icy comet. We're going to see what it looks like tonight. The other night we saw it. It had a tail on it that we could see. We saw that nice blue-green glow, the green from cyanogen, which is a carbon and nitrogen molecule bonded together. And diatomic carbon molecules, carbon-carbon molecules, that also generate green light when they're ionized. So it's pretty interesting. So we will see what else we can see here shortly. But we'll be back to the comet, and it has to get a little darker, of course, before we see it. But we can try. Let me try that now, just to give us a little bit more visibility here. I'm going to go to 1 second. It looks like it's kind of dark out there, but you never know. And we have 0 gain right now. I'm going to turn the gain up to just 200 for now. All right, so the gain is the sensitivity on the circuit, on the camera circuit. And now let's set our camera to 1 second and see how bright it is. Yeah, there we go. Look, we got some stars. That's nice. So that's the Antares field around us right now. The blue glow that you see here in the view is related to the fact that the sun has only just set out there. And there's going to be some clouds, of course, visible in here, high clouds. So we're going to try and get rid of those in any way we can. Hello, D. Smith. Good to see you. And Only Drexy, how you doing? That Only Drexy is cool. Been here before. Good to see you, man. And let's see now. For those just joining and who haven't been here before, I'll just give you a quick tour. This here is the telescope control section over here. We move the telescope from here. That's the telescope in the building right there. This is our computer for the telescope. That is skytourlive.com. That is actually the site, that's the portal site, the portal to everything that is SkyTour Livestream. This is the view, the main view. We will expand that to the full screen on good objects. And this is the camera control section over here, which allows us to do everything that we do. Over here in this lower area here, you're going to find all the data associated when we start stacking images, when we start making sandwiches of images to bring out the details and get rid of the noise. So that is pretty cool. You'll see that too. All right, so again, we're just waiting for it to get a little darker, and then I'm going to do a focus setup here too, Daryl.
All right.
First, I'm going to connect the focuser. All right.
While we're waiting,
yep.
Antares there. Antares is a red supergiant star. It's a lot like Betelgeuse, and it is another very good supernova candidate down the road.
Oh yes.
Antares is the heart of the Scorpion, and it's well past the meridian by 10 o'clock now. It's already westering. Summer goes fast, I'll tell you. The stars always seem to slip by quick in summertime.
I know, I don't like that.
Yeah. Well, late sunset, early sunrise.
Yeah.
Seems to go faster.
All right, I'm doing a focus setup here. Basically, we're taking sampled star images here, and we're building a curve down below here. And that curve should ideally look like a parabola. It kind of goes like this. And at the center of the bottom, the lowest spot, that should be the best point to focus. We can see our curve starting here. It looks like it's going down here and then coming up. I predict they're probably going to put a second line right about here. And that'll be about the point of best focus. So we're at 7 steps out of 12. And the more points we get here on this curve, the better the focus will be. So you can see now the lowest point in that curve, right about here, and it should actually work very well. Let me just put this back. That was, here we go, a little bit lower. Okay. Now, if it doesn't work, it means that we didn't, we waited, or it wasn't quite dark enough to do the focus. So that's what we're going to wait for here.
Sometimes I wonder if the ancients didn't know more than we think they did.
Oh, really?
Yeah, well, the scorpion killed Orion the hunter.
Yes.
He stung him, and the gods put the two in the sky, and they put them as far apart from each other in the sky as they could get, so they would never fight again.
Yep.
And when Orion sets, Scorpion rises, and Scorpion sets, Orion rises.
Yep.
And so we have the two best supernova candidates in the sky, two of the best, close by, and the ancients put them about as far apart as they could.
Opposite sides of the sky.
Yeah. Just idle thinking, I guess.
Yeah,
Blabbering.
That's cool.
Antares is marginally closer than Betelgeuse, perhaps. I think it's 600 some odd light years away. Betelgeuse is about 700 or so light years away.
Yeah.
But they're comparable. And when we look at Antares there, I have never seen it myself. Antares is a double star. There's a little dim secondary star very close to it. They say it looks green, but that's only a contrast effect. I have looked for it, and I saw maybe a little bit of a glint very close on one side, but I've never separated the binary from the primary, the secondary from the primary.
I'm getting some light cloud interference with the focuser, so I'm just working on it. Hello, Alice. Alice is here. Okay, I'm going to reset this and stop. Okay. Duh, I was going the wrong way. I got you. All right, fair enough. All right. Let's reset. Scan out.
Antares being so bright won't affect the focus run, will it?
No, it shouldn't. It shouldn't. The focus run is improving as we're watching it right here. You can see it's getting better and better. More stars are being captured. I'm actually zoomed in here too, so if I actually zoom out, you'll see the stars that are being included in the focus run. And if I zoom in, it doesn't mean that they're getting cut off. They're just outside the frame. The whole frame is being seen.
Yeah.
Izabela, this song is called Discovery, and it is really quite epic. It's just beautiful to look at the sky. And we're building our curve here now, and we should see a line of focus show up probably right here. There it is. So there's our line, and the focus is through it. Line of best focus, and after we get our last step, we'll tell it to go to that focal point. Alright, and then we'll have, there we go. So now we just go to the best focus point. The focuser will scan all the way out and in. The reason it does that is it actually gets rid of something called backlash. So it allows the focuser to go through and back again. Hello, Fun in Oklahoma. How are you? Good to see you, and thank you for that compliment. All right, we are now focused, so we'll get rid of our focusing system. And we should be all set here. Alright. And, alright. So now, without further ado, let's see if we can check out something that is really important to check out before it's no longer visible. That's NGC 4647. It's way over to the west, but if you watch the telescope up there, you'll see it move. We're going to try and do this. The reason is because there is a supernova in this galaxy, and we'd like to see it. I think that we've seen it before. I know we've seen it before, but I would like you to see the progress. I think some of you remember what we saw when we looked at it. It was bright blue when we first saw it, and then it started turning orange and then fading. And we'll see if we can even see it now. Hello, John G. Good to see you. There we go. So we're heading for the supernova, right? And we'll pull it back. I'll put that on in a bit. All right. First things first. Now that we have our focus, we can get rid of this. There we are. And let's bring up our planetarium and head over to this galaxy. Here we go. You watch the telescope, you'll see it says high precision slewing right there. And the telescope is now swinging over, and it's going to put a bright star in our view. If there's no clouds over there, good, we'll be covered. This is the star it's probably going to use right here. So it's going to center that star up, and from there it's going to jump to NGC 4647, which means New General Catalog 4647. So Vindimatrix is when it's centering up here, and I am gonna, if I come back to auto mode here, so you can fit the frame of the camera, and here you can see how it's centered. I was actually moved down a little bit. So there's Vindimatrix right there, and now we're heading over to the galaxy, and we should be able to see. There it is. It's there. The galaxy is there. It's a faint smudge right here, right now. And we're going to set an exposure and try and capture this, because it's really almost setting. All right, you ready for this, Daryl? You ready to see what we got?
Sure.
Yeah, me too. James Dugan. Hi, James.
Hello, James Dugan.
All right. So let's do a 20-second shot here, and let's remove our hyper field view here, and let's go into our live stack. And this is the information I was telling you about. This stuff shows up when we start stacking imagery. Okay. So let me move me out of the way. Not that. Let me move this out of the way. There we go. All right. All right, and now let's see. Let's get another view of this. Okay. Color correction. Bam. All right, and let's zoom in and see if we can see our supernova. Supernovae don't last long, but this one's still there. Look at that. Hey, Crazy Metal Chick Stewart.
Sure is, isn't it?
Yeah. Now you see the noise? That's going to disappear like this next shot. Ready? Watch this. Okay. Let me actually just do a correction. So now you can see this right here. Now we have clouds. That's why this looks fuzzy all over here. We're actually looking through some clouds right now, but it's not stopping us from seeing our supernova. All right, and that's what we're seeing right here is the supernova right there. Okay. So imagine in this galaxy, if you were in this galaxy, you would be seeing a star that has blown itself to pieces if you're on that side of the galaxy. If you're not, then you might not see it at all. But we can see it from millions of light years away. Sean Farva, thank you. Sean, you want an autograph book? I wish that you were at one of the conferences. I would have done it right there for you. Okay. Again, we've got clouds. That's why you see it looking as ugly as it does over here. Right. But there are clouds over there, and you can see the cloud bank pretty clearly here. Yeah, there it is. But it didn't rob us from actually seeing our supernova. That's really cool. We got to see the supernova. Alright. It makes the data look pretty bad, you know, at least now, but that's what happens when you're looking through clouds. This is really what it looks better this way, but it's still, you see the cloudiness. That's the light clouds are looking through. But there we go. That's our supernova. Not bad. So we've stacked 9 images here. We'll stack a couple more just to have a record. Actually, I'll stack one more and then head over to Comet K2, which I think is pretty awesome. I think it's going to be important too to get the coordinates of it. I have to get the coordinates of it again. Did you want to do that at Sky Live?
Yeah, give me just a second.
Sure, thanks. And I'll type them in. Crazy Metal Chick says, my boyfriend and I have a question regarding the opposite of black holes. That would be the white hole, theoretically, but yeah. Go ahead. Put it out there, Crazy, and I will try to answer it for you. James Dugan says, Mark, what is making the supernova last so long? Well, you know what? Supernovae take up a lot of area in space. When they go off, the star explodes, and it's not like it's an instantaneous, massive explosion that's over in a short amount of time. It's actually an explosion that ramps up, okay, and then ramps down slowly, because when an explosion happens, the explosion actually happens rapidly. The core of the star will collapse within a quarter of a second and cause this rebound effect that will then cause massive shock waves moving through the star, which will completely disrupt it and destroy it. And that process happens over a period of time. It doesn't happen instantly because the star is so massive. So it's going to be several hours over which that star actually does that. But then that material is very hot. And as it expands outward, it's colliding with other material and it stays hot. So it takes time for that material to lower in temperature, okay? And that's what we're seeing here. We're seeing a supernova that is still lowering in temperature, and they can last for a few months. This one already has. I think we started watching this one in March. No, May.
No, April.
Was it?
The supernova happened in late March, and we first looked at it in early April, I believe.
I think you're right. I think it was April 4 we actually looked at it, actually.
Yes.
I kind of remember that. Sorry about the clouds, but you know what? I'm trying to eke out a stream tonight, even though, it's not the best viewing. But we do have a number set here, so we are going to pause here. I'm going to color correct again. There we go, and then I'll save it just like you see it. All right, so
Ronald,
we're saving the raw. Go ahead.
I'm sorry, Ronald asked where this is in the sky. It's in Virgo, Ronald. It's in the Virgo galaxy cluster.
Which is actually setting.
Yes.
Okay, so this was our first object we got, and it won't have a title because I forgot to put the title here, so I'll just do it again. So I'll just say NGC 4647 SN. Okay, so that's
I'm
SN.
actually kind of surprised we can still see it. I mean, heck, it's been, going on 4 months now, I guess.
Yeah.
Yep.
Yeah. I
It is
know that they last a long time.
yeah, it's definitely dimmed a lot.
Yeah. The color was blue and a little orange, and with the clouds, we're losing some of the color here. But we'll do our best. Okay, don't worry about that. I'll fix it. Anyway, so there we go. And now I will move us out to the full fixture. You can see the clouds interfering with us now. And then you see where they don't. All right. So thank you, Vera. That's very kind, Vera. You're sweet. Thank you so much. All right. So now, Daryl, you gave me the coordinates, I believe, in the chat.
Yes.
1639.57. Yeah, we're going to put those in now. And that's going to take us just north of Antares.
Yep.
1639. Okay. Yeah, move you out of the way. 1639.57. So we can set manual coordinates of things we know. And in this case, the supernova is one we know. I'm sorry, the comet is one we know. Now, it was at -5 degrees declination the other night. Now it's at -7.
Yeah.
And that's still well up enough in the sky for us to see without any problem. -7, 25, 14. Okay. Let's go see a comet, guys.
Yeah, it has actually moved toward Antares. I'm almost on a line toward it. It's dropped that into almost southernmost Ophiuchus now.
Okay. All right, we're gonna do our view here, which gives us the view for the finder. All right. All right, and this is going to be Comet K2 Panstarrs. And it's centering up the star, and then it's going to move to the field. Let me remove the title here for the minute. There it is, right there. Look at that. Here's our comet.
Yep.
Right here. Okay, so we're going to bring this down. Don't worry about the colors. The color rendering, again, is due to clouds and the fact that we're still getting a little bit of the sunset residual reds in our views. Yeah, I know, Marianne. Isn't Vera wonderful? That's just amazing.
Thank you, Vera.
Okay, so I'm going to move this down.
A mole is here.
Hey, Mo, how you doing? Let's head east a bit. Move it in the center. Okay. Let's go north a little bit, too. Put it a little bit below. Thank you, Sean. Well, that's very kind of you, man. Thank you. All right. So kind. Thanks, brother. Okay, here we go. So now we're going to let our system lock on. You can see above the skytourlive.com. It's searching for stars, which it'll certainly find. And it takes about 11 seconds to lock on. And then, as you can see, it starts guiding. And now that it's guiding, we can take an image. Let's do 25 seconds. All right. And then we're going to get rid of our hybrid finder view and go into a stack. And clear the previous stack. And this will be Comet 2017 K2. Yeah, you may not see it yet, so let me just take care of that. All right. Now let's add a little processing to show that comet. There we go. And it looks like we've got a satellite here as well. Well, look at it. Looks pretty nice.
Uh-huh.
And it's somewhat cloud-free, so let's let this develop a little bit here. Marianne, shh, don't tell people that. You'll scare them away. I'm kidding, of course. Marianne says Arizona is going to get lots of rain in the next 5 days. I did see that there's going to be some rain.
Us too, hopefully. We need it as usual.
Yeah.
Oh, I'm sorry.
No,
it cooled off wonderfully here this afternoon. It was 96 here by noon today, and cold front came through, and it's down. I think it may be in the 60s here now.
Wow.
It's supposed to only be a high of 82 tomorrow, and
fantastic.
80% chance of rain.
Okay.
We need the moisture as always.
Yeah. I guess that's true. And if you're not an astronomer, you don't care about, the problems with the sky. I get it. Okay, so this last time we looked at it, the brightness of this comet was 10.97, and now it's 10.95. It's gotten a little brighter, but it's also getting closer to the sun. And it's going to go around the sun in December. And it's in the constellation Ophiuchus, as Darryl mentioned a few times. And as far as details, well, it's in the constellation of Ophiuchus, like I said. And there's a finder chart we can put up, I guess, but I don't know. It's actually, from us, the distance is 273 million kilometers, which is literally almost 2 astronomical units. That's how far away it is. And the light takes, 15 minutes to actually travel from the comet to us. So that's about, how far it is. It's actually quite far away.
Yeah. The comet's far from us, and the comet will never really get very close to the sun. At its close, it's still going to be farther than the orbit of Mars. I dare say the comet's going to be hanging around for quite a while, be visible. So
I agree with that. And the other thing too about the comet that's interesting, and Darryl would agree with this too, I'm sure, is that this comet, when you have a tail of a comet, when the Earth goes through the tail remnants of a comet, the dust tail, we see meteor showers. Well, this comet is literally going to stay, about as far away from us as Mars is. So it's not going to ever cross the Earth's orbit in any way to deliver a stream of particles that could become a meteor shower. So we're not going to see that happen with this comet, very likely. Now, things do drift in the solar system, and things do get pulled by the sun's gravity, so the dust tail could conceivably be altered in its orbit by Jupiter's gravity and whatever. But, it's going to be kind of a ring of debris, an ellipse of debris in the solar system that will kind of orbit in the same position unless something really bothers it. Let's zoom in on this. I'm glad we got our 2 goals done tonight. My goal was to get the Comet and NGC 4647, the Supernova. We got both.
The Comet, to me, does look a little different than it did the other night.
Yeah.
It's a little more lopsided. There's more on the left side there.
Yeah. Remember I talked about that V?
Yes. The
Okay.
east side, I guess, or yeah, the east side in the sky.
Yeah.
You can still see the
Tails.
dust tail,
Tails going there.
and the coma around the comet looks a little more extended there to the east also.
Yeah. Amal, thank you, by the way. That's very kind of you. Thank you for the donation. It is. Yeah, this is a beautiful comet, and I always want to take advantage of a comet. You know, there's just no reason not to. It's so beautiful.
Oh yeah.
You know, gotta love a good comet. In fact, what we could do is, since we're doing this, why don't we just let's see this guy. Yeah, there we go. Look at that. Now we got our comet. Oh, we got satellites too zipping through.
Yeah.
This one's gonna keep coming through, but its tail's gonna get tail's gonna basically get crossed by that, but it won't be too bad because that's one-time data that's gonna fade over time. Look at that. That's nice.
And thank you.
Loquatch. Loquatch asks, how much would I have to pay for a setup like this? Well, there's a lot that goes into this. And let me just pull out of the big view so you can see it better. Okay. Up there you see the telescope. Up there you see the control for the telescope. This is the main view that you're seeing through the special camera, dedicated astronomy camera that we have. This is the telescope, the camera control system. The camera itself is cooled to minus 10 below zero, and it's currently hovering at minus 5.3 because the temperature out in the building is 34.8 Celsius. That's pretty hot. So we have a thermoelectric cooler that's cooling the sensor to get rid of noise. So basically that means you have a Loquatch. Means you have a camera, a dedicated astronomy camera. You'll be looking at anywhere from $1,000 to $3,000 for that. The telescope, anywhere from $5,000 to $8,000, kind of like ours. And then the control systems, the control program, the building. You're looking at anywhere from $5,000 to $8,000 to build the building. Then you have to have automation built in and redundancies. We did this entire project on a GoFundMe. I am, for the rest of my life, I will be grateful to all those who donated to this project because it showed me how many people are hungry for knowledge about the universe. And you know, as an astronomer, that's what I went to school for. I have always felt that astronomy has been too much of a science that is, you know, seems to be hidden in terminology, and people can't reach it. So my goal has been to make astronomy reachable for everybody, and so that's why I'm doing this. That's why this became a obsession. Now, what you don't see behind me is the telescope for the East Coast Observatory. It wasn't an observatory out here. In fact, it was the first one we had. But we're actually building another building here, and we have a special system we developed for that one. And I think it's pretty cool. And it's going to have 2 telescopes mounted on the system, so we'll have cameras on both. So we can use a 5-inch refractor that's mounted on this and a 10-inch Schmidt-Cassegrain system as well. And we're also looking at making a remote observatory that is touring the country. We're going to take it all over the country. That's the kind of thing that will be a game changer. Bring astronomy to everybody. And if it's cloudy at the site we go to, we'll just open this building and show people this on the big screen. So it's going to be kind of fun to do that. So there you go. You can add those numbers up that I shared with you, and you get an idea. But you're going to be adding up. You're probably going to be anywhere to between $10,000 and $15,000 to do this. You know, and you have to be obsessive.
Excuse me.
Sure.
I've seen this question asked a lot on Reddit lately. Some of the subreddits I visit, space and astrophotos and stuff, people always go, golly, I want to do that. How much would it cost? And the usual ballpark number they throw around is $10,000 to really get equipped in modern digital astrophotography.
Yeah.
The bells and whistles and all, and that discourages a lot of people. With inflation going on now,
yeah.
I have been watching telescope prices, and everything is through the roof too. It's just getting more expensive.
Yeah. One of the problems is that you don't have to have these types of systems to do astronomy. If you want a good telescope, the Celestron 6 SE is a good one. There you're not going to spend thousands of dollars. You're going to spend maybe $1,000 or $2,000 at the most, and you can have a nice system that you can tell it to look at different things in the sky, and it will automatically go there. Now, integrating it with a system like this, where we actually will look at our sky through a planetarium view. Well, this is a bell and whistle that we added. Okay, it's nothing you have to use. The telescopes usually have that. Okay, but we added this bell and whistle. After we look at this comet, by the way, we're going to go to some nebulae that are in the southern Milky Way sky here, or the southern sky. We might be clear down there, so I'll have to see. But we're going to check out the comet for a little longer here. Look how beautiful that is. Okay, so now we can go back to pull this to full screen here.
John G., right now it's basically north of the star Antares in Scorpius that we talked about earlier.
But it's not just directly north. It's a little further up. Actually, why don't we just get him a value? We can do that. Okay, so the telescope is pointing at that place there. So if we zoom out a little bit, you'll see now here's Antares, okay? And we're looking, let's see, this is, that's got to be where we're looking here. It's 20, 25, okay, so 5, 10, 15. It's about 25 degrees north of Antares, basically. So, because this is minus 20, minus 25, you know, so it's like 5, 10, okay, maybe 15 degrees north of Antares. Thank you, Loquash.
And you might pick it up at a good set of binoculars, but you'll probably need a telescope to see it. It's not very bright. I'm going to post a link in chat here in just a second that might help people along.
Okay. This is looking really pretty tonight. Look at this. Izabela did some processing on the comet herself and did a very nice job, I have to say. We did processing as well. But I do want to mention that she's a very talented artist. And as I said to Izabela, please put up your link for your site so people can see what you do. Because you're a brilliant artist and you deserve a lot of attention. I see her smiling at us right now.
She never shared her comet image with me. I don't think she likes me anymore.
That's not true. Now, our star artist that we have on SkyTour Livestreams team is, of course, Tara Diulis, who is in the chat. Tara made our door. The door of our observatory is made of bottle caps. You might say, what? And what Tara did as an artist, I left it entirely up to her to do something creative. She had been collecting these bottle caps for years and years. As an artist, she saw value in a lot of different things, especially if they're colorful. And she collected these wonderful bottle caps, and she created a masterpiece of the Orion Nebula in a stylized image on the door of our observatory using just the natural colors of bottle caps from different types of drinks. For instance, Bud Light is a blue. Okay, there's this orange soda that's a red, or an orange rather. And she did this, and I have to say, I cannot believe the job she did.
Well, a lot of beer, too.
Right, yeah. Amal says, yeah, Tara drinks a lot. No, she doesn't. She got the bottle caps from a place that she worked, I believe. You know, look at the tail. The tail is actually very visible. This is only a 25-second exposure. To get this last time, I needed to take a 50-second exposure. Do you remember that?
Uh-huh.
Yeah. So we're going to actually... we've captured 37 frames. I'm going to pause it. I'm going to save it. And it'll go up to our database right now.
Did you ever pick a winner for the...
No one ever guessed.
I guessed.
You kept guessing the same number.
Well, yeah.
And it was always wrong.
It's 1,326, if I remember right.
Yeah, that's what you said.
My mind's not totally shot. All right, 1,327.
No. Okay. So, let's just save this exactly as seen now. Alright, now what we're going to do is we're going to change this exposure from 25 to 45 seconds. No, 50 seconds. Alright, and we're going to start taking pictures again. And we're going to see what we got. Alright, so our stack is here. We're going to clear the stack. This image is saved in the database. Okay, and our progress bar you see over here. This yellow bar is a progress bar that's going to show us the image. It's building up on the sensor, the new images on the sensor. It's not affecting this. This is an image buffer after it's been read out from the sensor. But this will be a 50-second shot of the comet.
Mark, could you excuse me for just a moment, please?
Sure thing.
Be right back.
Okay. Hey, DPFX, how you doing? Gliese 581G. Yeah, that's a amazing planet. I'm hoping that might be a planet that will be a habitable zone. Well, it is a habitable zone planet, but a planet that's actually populated with some kind of life. We'll be able to see that, with the James Webb Telescope. There's some reasons why we can do that. Oh my. Here we are. Look at this. This is beautiful, guys. Now that green you see in the comet coma here, that's called the coma. That green is actually a really interesting color, and it's a color generated by the two things actually. Cyanogen, which is like a cyanide, and that's CN, carbon and nitrogen bonded, and by carbon molecules, and these carbon molecules are making this green glow here along with the cyanogen. So those two things together will form this green glow that you see in this coma, and that's something that is characteristic of comets. And excuse me, Flammarion in the 19th century had said that comets have the cyanide in their atmospheres. The coma and so forth, and that maybe if that comet crossed the Earth's path, we would be killed by it, by the cyanide. Well, that was entirely wrong. Now look at this comet's beautiful. I got it in the palm of my hand. But let me tell you, this comet and comets like it really never did pose a danger to us, ever. So that is something that was just, part of the mythos of the lack of knowledge in astronomy at the time. Welcome back, Daryl. I was talking about Flammarion and the great comet pills and the theory that cyanide would kill us.
Oh yeah, yeah. Sir Arthur Conan Doyle, the guy who wrote the Sherlock Holmes stories. Yeah, he wrote a story about that.
That's right. I forgot about that. You had mentioned that last time we talked about it.
Yeah, that the Earth passed through a comet's tail, and everybody seemed to die, and then everybody woke up again.
Uh-huh.
That was the what's the guy's name? It wasn't Sherlock Holmes. Doyle wrote the original The Lost World story that I guess, all that was taken off from. And there was Professor Challenger, I think it was. He was the hero of all the Lost World stories.
Okay.
I think it was a Professor Challenger story. Can't think of the name of the story offhand.
All right.
Give me a second, I'll find out.
All right. Okay, we're actually right between cloud banks right now. So I would say that tonight's stream has been a really good success comparing to what it could be. And we got this beautiful comet here with this nice long tail. That's beautiful. Tara, thank you for coming. It's good to see you. You take care. Jay Trochi, how do you say that? Thanks for coming by the way, and checking us out. It's really nice to see you. Dean Bustador, how you doing? Welcome. Yeah. So we're just, like I said, we're actually doing our best here to try and hang out and make sure that we capture what we can. Once I'm done with the comet, I'm going to go to some nebulae if we can do it. We might have clouds, but we're going to try it. Very good. All right. There's a Starlink satellite that came through. Alice Pooper says, how many billion light years is that tail? Well, the tail is going to be in millions of miles. It's not going to be in the light year range at all. But that tail is going to be, again, they could be, overall, if you count the rest of their orbit, those tails can actually go hundreds of millions of miles easily. And that's the dust tail we're looking at there. But there is seemingly a mixture of some blue in here, which would be the ion tail, and it might be shrouded a little bit by the dust tail. We might not be able to see it entirely at the moment, due to the geometry of how the comet's facing and so forth. But I'm not sure. I don't really know, because I haven't looked that part up yet. But I do believe that this is probably one of the finest views of the comet that we've gotten to date. Look how sharp this dust tail is on this side. Looks really nice. Let me go back and check out the telescope here. All right. Yeah, so we're looking, as you can see, we're looking pretty much up in the air there. So that's good. We're getting a good view. There we are. And let's check out Ophiuchi here. Let's go. We're actually very close to the Milky Way right now. And it might be nice to check out some of the Milky Way that's nearby. I'd like to do that. Just to show you what we're trying to get at once this monsoon season goes away and we can actually look at things. Cosmic Ray asks, any optical filters in the system? Yes, sir. We're using special filters. We're taking a slice of what's called hydrogen alpha, which is the red light given off by nebulae. We're taking a slice of the oxygen 3, which is that bluish green like we see with the Dumbbell Nebula that we show sometimes, or some of these planetary nebulae. And we're taking a slice from this sulfur 2 realm as well, which is responsible for some of the red and some of the other colors we see in nebulae. And together those three are combined in one filter. So the filter looks like a mirror when you look at it. Yet somehow when we point at the sky, only the light we want gets through, and that's why even on moonlit nights we see beautiful vistas in the sky. The filter we're using could be used in a light polluted environment, and we're just using it here to literally sharpen and get a more exacting view of our night sky and the objects we look at. Look at that comet. Actually, Daryl, that's a beautiful view of the comet. It really is.
It is.
Hey,
I have a favor to ask.
Sure.
When you decide to go look at other things, could we take a quick look at Messier 4, please?
Oh yeah, that's right near Antares.
Yeah.
Okay. All right. Well, I got 12. We got 12 stacked here. That's K2 Panstarrs is there. We're gonna go into our live stack. We're gonna pause it right here.
We don't have to stop yet on my account.
Oh, no, I was only gonna do 12.
Oh, okay.
We did 12.
That's
so
a very nice
save.
image.
It is, and we're gonna get this beautiful comet saved up. And when we hit save here, you might ask, well, where's it going? Well, where these images are going is they're going up to our server, and they're going up in just a few seconds. So within a few seconds, if you go to that site, skytourlive.com, and scroll down a little bit, you'll see, take me to get these images, and it'll take you right to our portal database site. So go to skytourlive.com, and that's our entry point to all good things SkyTour Livestream. I literally whipped that site together in an afternoon, no lie. I knew what I wanted. I put it up there really quick. I was a web developer in the past, and so I was able to get what we need up there so you can check it out. Shane D45 asks, can it be seen with binoculars? And Daryl says, probably need a telescope, Shane. It's true, because this comet is literally almost 11th magnitude. And that means that it's 25,000 times fainter than the star Vega in the night sky, if you go by magnitudes. So that's a pretty dim object. But for a dim object on a night that's not too perfectly clean for us, that's pretty good, huh? That we can actually see this tail of this comet. That's not bad.
Yeah.
I think we did okay. But what we're going to do now, since I saved this already, we're going to clear it. We're going to get rid of the stack and go back to our 1 second time integration here and bring up our enhanced hybrid view. There's the comet. This is live every second. It's a 1 second view of our comet. Okay, 1 second exposure. So you can see the noise in the background changes every 1 second. All right. So that if we recorded this, we'd watch this traveling across the sky. We took images the other night of it, and over the course of just taking an hour's worth of images, we watched it traveling through the sky. It was pretty cool. All right, so now Daryl wants to see Messier 4, which is actually right here. It's called the Crab Globular Cluster. I don't know why, but it is. Well, we're going to go now. We're going to tell it to go there. So we're telling the telescope to go there, and you'll see that the telescope will move now. We're doing this precision slew. And what's going to happen is it's probably going to bring in this star right here. This is Antares. Messier 4 is just out of view to the right. Actually, I might be able to see it if we go and fill the frame with the image. Yeah, there it is. So there's Messier 4. So it's centering up Antares, and then it's going to take us over to Messier 4 right there. Thank you, Sean. Thank you, Jay. I spent some time getting the music. Sorry, I was mistaken about the location of Messier 4. Here it is.
Yep.
Okay.
This is the closest globular cluster to Earth.
And when we zoom in, you'll see that it's really quite beautiful.
Yep. And I can already see the one thing I wanted to look at tonight.
What do you want to see?
That line of stars running vertically from top to bottom through the center of it.
Right here.
Yep. Globular clusters all kind of look alike, folks. But when you get to where you've looked at a bunch of them, you'll see that they all are different in their own way.
Yeah.
And M4 here, Messier 4, is known. Do you see that line of stars running through the middle from top to bottom? It's really there.
Yeah.
And it's well known for it.
Yeah. All right, we're going to take a 15-second stack of Messier 4. Okay. And I give it the title GC because it's a globular cluster. So now you'll see it show up. Boom. Beautiful. And then we're going to do a little processing on it and get rid of our other processing, which is interfering. And there we go. And now we'll color correct. Watch the noise cut down all dramatically here as we move into this next phase. It looks really pretty. Here's your M4, Daryl.
Yes, thank you.
Yeah.
It's about 7,200 light years away.
Okay.
And if I remember correctly, it's the closest globular to Earth.
Wow. Now,
Isn't
in
that
this
pretty?
region, yeah, it's beautiful. In this region of the sky, this particular cluster is also situated near the Milky Way. So you might see clouds here, and these are not necessarily clouds of the earthly kind, but they might be star clouds. And there's a lot of that out there. And if we back out, let's see what our stack shows us. Okay, this looks like there is a globular cluster up there too. That's what I was pointing at before.
Mm-hmm.
Yeah.
I forget which one that is.
Yeah,
Stellarium would probably tell us.
It will, yeah. I'm gonna head there now. So let's oops, over there, we'll do this. Alright, let's zoom in.
NGC.
NGC 6144.
Yeah.
That's Melamed 147. Another catalog object. That's good. Very cool. And we are, the Antares Nebula is all throughout here, so we may have some clouds here, but we also have we also have Milky Way getting in here too. So I'm going to do something really quick here, just to see what's out there for us. And that's gonna be this guy. Let's see if this will show us. I'm gonna do a 15-second single acquisition of the sky with our all sky cam. So let's see if it's gonna work. I know there was sometimes it collides with the systems we have running. There we go. Oh, that's not bad. Look at that. So our sky is pretty clean. This is the southern hemisphere, the southern down here. Okay, so we're actually looking pretty good. And we have some clouds, but we have a good night so far. I'm not going to go anywhere. Thank you, Vera. Nice. All right. So this is good. So we're going to take that away. Take that away. All right, I'm happy. Okay. I've got M4 in here. We've done 15. We'll do 15 stacked. We'll let the 15th one come in. And then we'll pause it and take an image. There we go. Pause. Save it exactly as seen. And save the raw data.
Yeah. That line of stars just kills me. I don't know why.
And it is just a line of sight thing too. It's not a real, I mean, it's there, but it's simply a line of sight thing. Cool. All right, so we're gonna get out of this stack. Go back to 1 second, and I'm gonna do a quick pick here. There we go. All right, and now I'm going to get out of our stack again because I didn't earlier.
Mark, they were talking in chat about Webb looking at Galactic Center. I mentioned it, and some other people brought it up. Was it you that mentioned recently? I saw this somewhere that the observable field of the Webb is sort of a donut shape, and that donut shifts over time as we revolve around the sun over the course of a year, of course. So like there's a certain window in which they can look at certain objects, and Galactic Center I mentioned is pretty much prime time right now, but that donut shaped observing field of Galactic Center actually may not be in it right now, that they would have to wait for it to shift over into the donut. Do you know what I'm saying?
I do. Yeah, I don't actually know. I don't know how that's being handled logistically. So that I don't know.
If you imagine the Webb and that sun shield and everything,
yeah.
Well, the Webb is sort of locked into looking around sideways. Yep. So the shield stays blocking the sun at all times. And so it can't look anywhere toward the sun. And I think actually it cannot look directly away from the sun either. That it's going to look sideways all the way around it, making that donut toroid shape. Okay. And as the sky shifts, as we orbit around the Earth, orbit around the sun, over the course of a year, various objects will move into that observable field.
Yeah.
They might actually have to wait until later in the year to be able to look at a Galactic Center.
Okay, I'm not sure I did see the list of objects they were going to look at first, and none of them were galactic center objects. Which, okay, you know, that's fine.
I know they looked at M74 recently, which is a galaxy in Pisces. And Pisces is pretty far over to the east right now.
Yeah. Okay. Okay, this is actually a really interesting location that's above Antares. This is called the Rho Ophiuchi Nebula. You can't see it yet, but we're going to try and bring it out for you. Alright, so step one, we're going to take a 40-second shot. We're guiding now. You can see our guider is up there doing its thing. So we'll take a 40-second shot right now, get rid of our hyper view, and go into our stack. Actually, we're going to do 40 seconds, not 40 milliseconds. All right.
Thanks for sharing that tonight.
Yeah, sure. And now we should be doing that. We're going to clear this, and we're going to be now looking at the nebula. Hi, Michael Klages. How you doing? What happened to Michael?
Kidney stones. Oh my goodness.
Oh. I'm sorry, Michael. Sorry, brother. Really sorry to hear that.
It's like peeing glass.
Yeah. Thank you, Daryl. That was a wonderful thing to just have to think about now.
Sorry.
That's all right. Michael actually had to live it. Sorry, man. Okay, so we're going to get a second one, then we're going to do some processing to pull the nebula. You can start to see the nebula, though, can't you? This is a dust cloud that surrounds Rho Ophiuchi, and it really is astonishing. All right. So now, let's go and let's bring out some detail. Check that out. This, you can see dark dust here. These are not clouds. This is dark dust. Our all-sky camera showed we don't have any clouds in there tonight. So we're looking at this beautiful sky, and we've only stacked 2 images, right? And if we were to just do a little manual process and pull out a little more and just show you what's really there, there's an awful lot hiding in here. And we'll see that shortly. We will see that shortly. This is known as the Rho Ophiuchi complex.
If you see wide field shots of this, it sits just above Antares, and wide field shots, Antares and M4 will be in the same field of view. And there's 2 big, long, dark clouds. Dark nebulae that are running over toward the east, and actually almost to the Milky Way itself. And if you've heard me talk about the Dark Horse Nebula before, or the Pipe Nebula, they actually intersect that.
Well, we may
really
be able
cool.
to look at that tonight too.
Yeah.
Privately, when I have time, guys, what I'm going to do is I'm going to create a mosaic of this entire area. So you'll get to see, at this resolution, you'll get to see this whole area. I think that's pretty cool. I just need time, and I'm not going to have you guys sit through this tonight because it will take a long time. You know. Now, what's that say about Michael Klages, that he just got back from the hospital and he jumped into our stream? That says that we got someone who's like real dedicated astronomer over there.
Or crazy.
I'd go for a dedicated astronomer.
Okay. Dedicated.
Yeah.
Thank you, Michael. We appreciate your support.
Yeah, he's good. Yeah. So this is looking nice. We've got 5 stacked here, 5 40-second images. And you can see how the color's developing here. And it's actually quite something. Let me just kind of enhance it. There we go. Speaking of enhancement, I'm going to add now a sharpening system here called the Unsharp Mask. Ready? I'm going to click this, and you're going to watch this dark. See these dark areas? They're going to kind of jump out at you a little more now. Ready? Watch this. So I click Unsharp Mask now. Now watch. Look at that. Now they're more well defined, aren't they? See that? They are. And that's something that we aim for with this. And the processing we do in here in no way affects the actual raw data. The raw data, we would have to do all this processing manually to make this actually happen. Okay, and right now we're not doing that. Okay, we're just letting it happen on its own, and then when we do the processing in this program, the processing here will actually will only take place in the actual image that we save as the image you see, but it doesn't stay there. Okay, in the raw one. The raw one, this doesn't affect the raw one at all. Kathy Pernisek is here. Hello, Kathy.
Can I ask a dumb question?
There are no dumb questions.
Well, you haven't heard my question yet.
Okay.
How can something called an unsharp mask make things look sharper?
You know what? I was waiting for someone to actually ask that question.
25 words or less.
Okay, that's like saying, give me the history of the Civil War in 5 sentences.
Well, you know.
An unsharp mask has everything to do with a matrix, basically. So imagine a pixel in the center and all the other pixels around the outside. Those are all taken together, and they're mathematically calculated to take the adjoining pixels and make their values something that will help make lines sharper. And why it's called the unsharp mask, that's I wouldn't. I'm already past 25 words.
Well, there's a thing on Reddit called Explain Like I'm 5. Like, you know, and I jump in on those occasionally, and I try to keep it simple, like I'm talking to a 5-year-old, and the darn moderators, as often as not, they delete my comment because it's too simple. You know, and I find that sort of insulting, because that's exactly what we're striving for, supposedly. Well, people go off on these long-winded explanations, and they're not keeping it simple, and they let them get away with it.
Well, you gotta have a thicker skin, no doubt about it.
I guess
you can't let people get you upset about things.
Oh, I'm not. I got used to that a long time ago. They just, you know, it's like the mods are forgetting the point of their own subreddit.
Yeah, exactly. This is a beautiful nebula.
It is.
These diagonal lines are an artifact in the system that I went out there to fix, but unfortunately, I couldn't get rid of them entirely because they're deeper in the system, and I needed 2 people to get into the guts of the telescope to do this, and I couldn't do it. So I'm looking out for one. Hey guys, I'm still here. It says to go. Move. Get out of my way. Move. Thank you. Yeah, okay. So, it's in the guts of the system, so I need a second person to help me out there. When I get a second person, then we'll take things apart and start doing this.
Do you look at that flat field thing you talked about?
I did. This is the new flat field we're looking at right now.
Oh.
I'll show you what I mean. Okay, if I just select none here, well, you know, it's not going to do anything because it's a stack, and every previous image already has this flat field applied to it, and I'll ruin the stack if I do that.
Well, some other time.
Yeah, some other time. All right, we have 13 images stacked here. You can see that beautiful, subtle, gorgeous clouds here. That's just beautiful. There's so much more data buried in here that, you know, it has to be processed and teased out, but it's really pretty. Okay, we'll do 15 of these, and then we're going to go to the next object. Okay, this is good. Let me try manual processing. Do this. Yeah, I'll do this. Let's see about this.
bckgrnd gave a pretty good explanation of an Unsharp Mask.
Yeah, and that's what Google says. He's right. The only thing that I want to say, though, is that Unsharp Masks using film you could do, if you recall, and an Unsharp Mask digitally is a different thing that accomplishes the same end. That's pretty cool. Well, thank you, PK Technician, PK Tech. All right. So we have 16 of these stacked. We're gonna come up here, and before I do this, I'm gonna change this to the Rho Ophiuchi complex. Rho Off complex.
I'm a Luddite at heart, I have to admit.
Why is that?
Oh, just at heart. I mean, you know, I was an industrial mechanic for 40 some odd years, and I worked on multi-million-dollar digital equipment and all sorts of stuff like that, and yet I'm still a Luddite deep at heart. I don't trust technology, and sometimes I don't understand it, especially that digital stuff, you know.
Yeah. Well, you're smack dab in the middle of one of the biggest digital systems there are, right here.
Yeah, I know.
I really want to come over here, and I've got to see. There's Baade's window. That window right there is the view right into the center of the Milky Way, or as close as we can get to it.
Yeah.
Would you like to view Baade's window?
Oh, sure. See that star Al Nossel there? That's the spout, the tip of the spout of the teapot.
That's right.
But for the classic constellation, that's the arrow. That's the tip of the arrow.
Mm-hmm.
Al Nossel means the arrow.
There's the arrow.
Yep.
All right. So what we're going to do is we're going to check out that little area that looks through there. Don't expect to see a window, but we're going to go now, and you'll see the telescope will move. But not yet. I've got to actually grab our 1 second shot, and then it'll be changed as soon as we come in. There we go. All right. All right, there we go. Okay, we can see Milky Way here. All right, let's see if we are where we belong.
And sometimes we don't see Milky Way.
Yeah, we're way down here for some reason.
Thank you, Izabela.
Thank you, Izabela. Okay. All right. So we should be... Okay, by the way, this square here represents the field of view of the telescope. All right. Now let's back out of here and see where the telescope went. The telescope sometimes goes to the wrong place because, not because of our fault, but because the database built into the system is wrong. And we've found a number of times when that's true. So what we're going to do now...
Looks like your pointer is down by the star Shaula.
Yeah.
Oh, there you go. You're moving it now.
Yeah. I'm getting it back. It went to the wrong place, but it, like I said, it does that sometimes.
Yeah.
So we're just going to come over manually. And what it means is that what it has for coordinates for Baade's window is incorrect in the system. And I can't correct that. So we have to live with that crap. So I apologize for that. But it's not just me with this telescope. You know, professional astronomers have this issue in big domes too. I had this issue when I was working in a big dome and with a professional system. I had to do that too. I mean, I shouldn't say this isn't a professional system. It really is a pretty darn good system. A professional system has like a university behind it. I don't have a university behind me. Not yet. But we're working on that. Trying to get that. Okay. There we go. So now let's go and reduce our speed. Head back west. You can see how many stars are in this view. It's just incredible. And let's come in. We should see. Okay. There's a globular cluster there.
Two of them.
Yep, right there. And if we look in Stellarium here, you can see the two of them.
Mm-hmm.
And the one on the right is literally superimposed over Baade's window.
Mm.
So this one, right here, is actually over Baade's window. So we're going to move a little bit to the west again. Pull this in. And we're going to do a time exposure to show this section of the Milky Way, which you're going to be amazed at. It's actually pretty interesting here. Okay. Alright, so here we go. And this should be pretty close. Yeah, we're good. Alright. So we're searching, as you can see right there, and once we start to do our thing, I can pull off our 45-second shot. Telescope should find its guide star here in a moment. There it is, and it's guiding. So 45 seconds, off we go. We'll do the live stack. And we're going to call this Baade's window. B-A-D-E-S window. Alright, and then in our stack, no. I'm going to clear it. Yeah. Okay, so here we go. Let's read it off the sensor. What do we got? Dear God. Talk about stars, huh, guys? Well, let's kick it back a notch. All right. Okay, now talk about starry sky, huh? That is amazing. This is our Milky Way, and right here is the area that's been identified as the hole through which we can see what's going on. Now you might say, well, wait a minute, is this the hole? Actually, no. That right there is actually dark nebula. That's dark dust between us and the stars behind it. It's more of a blocker. So you see, this is an area where there's stars with very little dust and gas that are blocking our view to the further beyond. So it's right here that is the most transparent part of our Milky Way that gives us the furthest view toward the center, but we still can't see the center. Not without special processing. And
Like
special,
Webb.
Like Webb, yeah.
Yeah. I hope they do that soon.
Yeah.
I've seen some of the recent Webb images. I think I sent you that one of M74 in infrared by Webb.
Okay. Yeah.
That it's a face-on spiral galaxy, but it looks so different. It's almost unreal looking.
Yeah. Well, in infrared, right?
Yes, and you're starting to see them doing a lot of multi spectral images now too, like combining Hubble, Webb, and Chandra, stuff like that.
Yeah.
At different frequencies, different wavelengths.
Mm-hmm.
That's a cool picture.
There's our Milky Way, guys. You can see these vast star clouds with dark nebulae interspersed in here, and it just makes you think, doesn't it? You say, man, how many suns are we looking at? Well, millions of them, right in this image, effectively. Jessica S says beautiful. Okay, Shane says wow. Yeah, I mean it's crazy how beautiful it is here. Kathy Pernasek says billions and billions. You know, I was an astronomer that was an amazing human being, and then I died. Well, that was, of course, Carl Sagan, my favorite astronomer. And I really loved that guy's approach. He made things understandable to the masses, which is like what I do. And I guess if you say, I was kind of modeled myself after Carl Sagan, I guess, in a sense, right?
Oh, me too.
Yeah.
I read everything of his I could get my hand on when I was young.
Yeah, so did I.
And Arthur C. Clarke. Stephen Jay Gould, too. Did you ever read him?
Yes, I actually met Stephen.
Oh, really?
Jay Gould. Yeah, I went to a conference and he was there, and I got to talk to him for a little while. Just like I met Kip Thorne. You know, I actually went to a lecture of Kip Thorne's, and I got to talk to him about black holes later. And that's when he talked about the Stephen Hawking, Kip Thorne paradoxical swapping of positions on black hole theory. Pretty cool. Give me a moment. I'm going to go grab myself a bottle of water, okay?
Okay.
I sense a good session here. I'll be right back.
Have you folks ever heard of Stephen Jay Gould? He was, oh God, what was he? He passed away some years ago. He did a whole series of really interesting books on biology, and I'd have to look him up. I forget what he was, paleontologist? Something. He wasn't a paleontologist. He was quite a guy, though. He wrote a lot of real real informative and often funny books on odds and ends of biology and evolution and stuff like that. And Carl Sagan, I grew up on Carl Sagan. I remember seeing Carl Sagan on the Tonight Show.
Oh yeah,
often
I remember that.
with Johnny Carson when I was a kid.
Yeah.
He did the original Cosmos program also, which
right.
was a landmark show. And of course, Neil deGrasse Tyson had to do it over again. I'll never forget, I have a really funny cartoon of Neil deGrasse Tyson getting into it with the planet Pluto. And Tyson goes, "Pluto is not a planet." And Pluto says, "Well, you're no Carl Sagan."
Speaking of Pluto, that's somebody else that I met and got to talk to at length was Clyde Tombaugh, the founder, the man who found Pluto.
I would like to have met him.
What a nice guy. He was a very small guy, wiry, and he talked like this with a little high voice, but excited. He was very excited about what he was. So we talked about finding Pluto and basically how that hit him, you know, when he realized it. Because at that time, you know, we didn't know how much else there was to find in our solar system. And when he found Pluto, it was a huge, huge achievement. So he was talking about that. I was sitting with him in the grass, actually, up at an astronomy conference, and I was just I was an astronomer, just attending, just to watch things. And I think that it was so much fun to listen to Clyde Tombaugh's approach to how he found Pluto and using the blink machine, the blink comparator stuff, to actually see it. And that was, again, when people were taking images on film. There was no electronic CCDs and CMOS detectors. It was all film.
Yep. He used an old-fashioned blink comparator to find Pluto.
Yep, that's right.
Yeah, he used one of the smaller telescopes at Lowell Observatory.
Yep.
And he was just a farm boy from Kansas who was an enthusiastic amateur astronomer, built his own telescopes, and he drew images of planets and what he looked at with telescopes, and he sent them off to Lowell Observatory, and without a college degree, they hired him anyway and turned him loose on one of their smaller telescopes, and he discovered Pluto with it.
Yeah, it just goes to show that sometimes the best achievements are those that are in the dreams of someone and not in the degrees of someone.
Oh yeah.
And that's something that I've always felt. You know?
Yep. Now, I was in Las Cruces, New Mexico back in 1994, I guess, for the annular eclipse down in El Paso. And Tombaugh was still alive back then. He was living in Las Cruces. And I thought of looking the guy up, but I didn't want to be a pain in the butt. Who knows? If he is a nice enough guy, he probably would have said hi to me anyway.
He would have.
I was tempted. I was sorely tempted at the time.
If I remember right, okay, when I was sitting on the grassy knoll, I thought it was him sitting near me. And I looked over and smiled at him. And he opened up a conversation with me. And he said, "So, are you an astronomer?" I said, "Yeah, that's right. Does it show?" He said. And he laughed, you know. It's like, "Oh, well, no," something like that, you know. I said, "Yeah, I've always looked up in the sky and felt that there's more out there than us. So I became an astronomer to research that on my own." And he goes, "That's incredible." I was. He told me about his work and stuff like that. I forget everything he said. All the anecdotal things were just priceless, and can't remember them, unfortunately. But I will say this: I do believe that Pluto is a planet, and I'm sorry. I don't care who argues with me. Pluto is a planet. It was captured in our solar system. Yes, it's on an inclination, okay, that makes it sort of trans-Neptunian type object. But I do believe that it is a planet. So that's me. I'm sticking to it. There we go. Well, there you go, folks. There it is. There's Baade's window. And Baade's window is right kind of behind this globular cluster here. You know, and again, you think of Baade's window as being a dark hole, but it's really not. It's actually the area where many stars are visible because there's very little gas and dust there. See? So if we zoomed in on Baade's window here, let's see if you can get a better feel. Let me see. You see a lot of stars, and that's the clearest view, okay, as opposed to trying to look through something like this. Now we're looking at black dust between us and the stars behind, and that's why the best windows in space are actually those that have the most stars, in effect, in this type of situation. I'd like to go check out some dark nebula while we're here, Daryl.
Sure.
Okay, so what we're going to do is we're going to take this. We have done 16 frames. I mentioned, well, I tried to type Baade's window, but it came out totally wrong, so I'll do it again. Okay.
You're gonna click box in Stellarium for Barnard objects.
Yeah, I am going to do that.
Yeah.
Yep. Let me just save the raw file and exactly as seen. You can follow Izabela's links that she puts up that I've seen her putting up tonight, or you can go to skytourlive.com or skytourlive.org and scroll down. That'll give you an entry point into the database, but she's giving you the exact link to the exact spot, so you don't have to wade through directories. All right. Wow, this is something. This is pretty. Really pretty. Okay, so we'll clear it. We'll clear this big, beautiful, pretty object because we saved it already. And we're going to go back to our 1 second shot here. Give ourselves our hyper view. There we go. Now we'll go back into Stellarium, and we have to do one thing, as Daryl was alluding to. Once we get back into Stellarium, we actually have to bring up our DSO, or Deep Sky Objects, and then click on the additional catalogs. We want Barnard objects. We want Sharpless objects, Vandenberg objects, and then Lund's Bright Nebulae and Lund's Dark Nebulae. And we'll do some Meloc clusters, and that's good for now. So when I come out of this, we're going to see that there's more objects available to us when we start looking for things. Alright, so there's Baade's window where we are, the Milky Way. We're going to go a little bit north of it right now, because I would really, frankly...
well, there's the pipe right there.
Yeah.
To the right, Pipe Nebula.
It is right there, yeah.
Yeah.
If check that
out? You can try. I mean, that's a Barnard object, I believe. The Pipe Nebula is a dark nebula.
Too.
I'm sorry.
Dark Horse is right near it.
Well, they're part of the same thing. The Pipe Nebula actually makes the back leg of the Dark Horse. The Pipe Nebula, I do believe, is a Barnard object, and it's hard to see. You probably have to have a really dark sky. It shows up well in images, though, and if you see the pipe the bowl of the pipe in the Pipe Nebula, where it's marked right there, pipe. If you draw a line from there to Baade's window, or to Al Nasl, there, the tip of the spout of the teapot in Sagittarius, the center of the Milky Way is just to the west of Baade's window, and just to the east of the bowl of the pipe. Yeah, and if you can see the Pipe Nebula, it doesn't show up well in that image, but the shape of the pipe, the stem of the pipe and the bowl make the hip and the back leg of the dark horse, and the front of the dark horse extends up and to the right, his head and his front leg. It's not easy to see though.
We're using Theta Ophiuchi to be the guide star, our waypoint star as I call it, to the Dark Horse Nebula, from which we will look at the pipe as well. There's a satellite coming through.
Thank you, Izabela.
Okay, so we are supposedly at the Dark Horse. So, shall we try?
You can try.
Absolutely. Let's do that. We'll do a 40-second shot. Drop that down, go to our live stack. You can see our progress bar over there is advancing, which is good. Alrighty. And when we look in here, it looks like we are in the region of the Dark Horse. Let's find out. We're about to find out. Here we go. 1 second, and boom. Alright, so what we're going to do now is go to our data, and we're going to process a little. And there it is. Look at that. Wow. This beautiful, beautiful nebula.
Doesn't look much like a horse in that, does it?
Yeah, well.
It shows up well.
It does. Show up even better as we stack more. Right now we have 2 images stacked. And I think I actually did not turn on our temperature compensated focus. So our focus may be a little off. But I can say temperature compensation now and see if it changes anything. It did. Alright. That's beautiful. So it's these dark nebula, guys, this is my thing. These dark nebulae are the place where solar systems, star systems, new stars, that's where they're formed. And they start in the cold, dark clouds of the universe. And when the star winks on, just like you winking, you know, When the star winks on, fusion begins in earnest. That star hugely lights up the cloud it's within, and if it's just dust, then the cloud looks like a bluish cloud. That's called a reflection nebula, because the star's blue light is being scattered by the dust particles. But if it's got hydrogen gas in it, which is more often the case, then the cloud might look like a mixture of blue and red, because we're seeing the hydrogen alpha emission, which is caused by the ionization of the hydrogen gas by that young hot star. Right here, we just have a dark cloud that's seen in silhouette against the brighter star clouds behind it.
If you see that fainter dark nebulosity there toward the right, that extends all the way from Rho Ophiuchi. Two big, dark, broad bands head to the east from Rho.
You mean this?
Yes.
Yeah, right.
That all extends all the way from over at Rho Ophiuchi. And
yes.
the Dark Horse and the Pipe Nebula actually connect to it.
Really, it is my favorite part of the night skies, the dark things you can't see. What hides in the dark is what brings life to the universe.
Can you pull up
Richard
Stellarium for a
Feynman.
second?
Yeah.
And, okay, Dark Horse. Does that give a Barnard number?
The Dark Horse number is also called the Prancing Horse Nebula. It does not give it a Barnard number as far as I can see.
There's B262 just above it.
That's that.
I assume that's a Barnard object, yeah.
Yeah, that's B262. In fact, we're probably looking at B262 without even realizing it over here. I'm guessing that maybe this. Notice how
I
much
would
clearer they're coming in. Maybe this.
Yeah, I would guess that darkest part there, a little bit to the upper left of center. That right
This?
there. Yes.
Maybe. But I would imagine
kind
this
of-
should be. Wow, this is a beautiful nebula.
It is.
Yeah, the music is good too. I like this music for this. This is like, it's like mysterious universe. Oh yeah. Very cool. We've stacked 8 so far.
It's a nice image.
Yeah. Cosmic Ray says he met Tombaugh at Cellophane. That's where I met Clyde. I met him at Cellophane as well, and we sat on the grass by the observatory there and talked for like half hour.
You know, when you said you sat on the grass earlier, Stellophane was the first thing I thought of.
Yeah, I went to
Should have said
Cellophane.
that.
Yeah, I
Cool.
forgot. I forgot.
I'd love to go to that sometime.
I wonder if it's still going on.
I believe it is, yeah. Stellophane is a big annual meeting of
Springfield
amateur
telescope
astronomers, telescope makers, I guess. Yeah, ATMs,
Yes.
amateur telescope makers.
Springfield telescope makers.
Yep.
Springfield, Mass. Wow. Look at the tendrils in here, guys. You can see how this stuff is shaping up. Look at how complex this is.
Uh-huh.
This is beautiful. Hard to imagine, but this stuff is actually moving and swirling long term, but you can't see it. You just see a snapshot in time For the length of time that a human being exists, that's way too short a time to see a change in something like this. And Michael Klages says the Snake Nebula is a cool dark nebula. Yeah, that's down below here, I believe. And I was thinking of looking at the Snake as well. I mean, we're technically where we're sitting now is like right about here, and the Snake Nebula is just out of view down below here. But
yeah, it was in the stellarium shot.
It was, yeah, but it's just out of below. It's out of view here.
Yeah. Just south.
So yeah. All right, so I've got let's pause the window. This. All right, we're gonna call this what it is. All right, so this is Dark Horse Nebula. I think Marianne must have fallen asleep. She was here for a while.
My foot fell asleep.
Wow. Okay, let's see here. 13 stacked. We'll go to 14. This will make a beautiful process. Izabela says, I have dark nebula processing phobia. I'll work that out of you. Hey, John Bailey, how you doing?
I bet the Boogeyman Nebula scared her last year.
Yeah, she did a nice job with that too, if I recall. Okay. Look at this. This is really pretty.
Yeah. Oh, the darker parts are really coming out now.
So I'm actually gonna let this go just a little longer. We try to bring that contrast out a little more. Yeah, there we go. Look at that. Wow. Jeez. You know, it was just, this is, guys, I gotta tell you, this type of view was something that was just in my imagination years ago. I never expected that I would be able to see this for myself, and never mind that, broadcast it to the world. But it's happening now. This is just incredible. Wow. Look at that nebula.
I see it pulsating. There's like a shift going on across the face of it. Does anybody else see that?
Pulsating? Like visually pulsating?
Yes.
Because it's a 40-second exposure, so you're not going to see any pulsating unless it's an artifact of the stream.
Then it quit again. Now it's doing it again.
Sure. Huh. It might be your monitor.
Might be hullabalootions too.
Might be what?
Hullabalootions. Hallucinations.
Yeah. Well, it depends what mushrooms you ate, for dinner.
I didn't have any mushrooms for dinner.
Okay. Cool.
Let's do the snake.
Yeah, I saw that. We can try that. Let me let's make sure what we got here. We have 17
Whenever you're
stacked.
done here, of course.
Well, I'm very happy that the night has turned out to be a good one.
Oh yeah.
I didn't expect we'd get one. Okay, here's 18 stacked. We're going to pause it here. I've got Dark Horse Nebula there, up there. We're going to save our raw stack. And we're going to save it exactly as seen. You'll see the FITS file is the raw stack, and then the PNG file is this exact image as you see it here. Really pretty. Okay. So that's going up to the server, guys. It'll be there in just a few seconds. So we will now come out of here. Go back to our 1 second shot. Not 4 milliseconds. That's not what I wanted. I want 1 second, please. There we go. And that's the view. You can barely see something dark in there. Okay. So there we go. All right. So now what we're going to do is come out of here. Come out of here. And we're going to drop down over here, and we'll check out the snake. And we're not going to have to do anything other than just go to it. So I'm going to first of all take us out of this mode. Give me back the view of the telescope, and we'll head over to the snake now. And this is for Michael Klages, who didn't necessarily request it, but he did say it's a beautiful object, so we're going to go and look at it out of respect for his thoughts on it. Let's go west.
That big rough square shape looks like a highlighted area in Stellarium, so
it is.
I bet there's something good there.
Yeah, the snake's there. You can see it.
Yep, the snake, the ink spot, Lane's Dark Nebula 70.
Yeah. Let's see what we
got. Barnard 70.
Yeah. Come over here.
Lane's Dark Nebula 37.
Yeah.
Bunch of.
Yeah, so it's in here somewhere. Let's go. First of all, that bright star there, Rho Ophiuchi, that's this star right here. And then this star right here is this star right here, which is B74. So those two stars are right there. So now you see that we are well placed for the nebula, which is right there. You can kind of barely see it.
Oh.
So let's
B74 is the Barnard object just above that star.
Okay.
I bet it'll show up when you do a time exposure.
Maybe so. Yeah, this will be a 50-second shot. I'm actually at 200 gain. I'm going to increase our gain. So let me stop that. I'm going to go to 300 gain now. Increase by 100. I normally do that, so let's do this over again. Alright. So all these shots today were taken at relatively low gain. Now we're going to go to 300 gain. Michael Klages says, I can compare your 15 minutes of F2 to my 4 hours of F4.3. Are you talking about this image that we're doing? Well, let me, first of all, bring back some moderate levels. Yeah, that's beautiful. Look at that.
Oh, yeah.
Look at all that.
Yep, and look at that dark cloud just above that second star down at the bottom.
Yeah, right there.
That's Barnard 70.
Wow. Yes, that's something else.
Oh, I've
you
seen
almost
this.
don't know where the snake is right there.
Yes, I've seen that.
Okay.
Cool.
Yeah.
There's a
We've
lot
seen
going
it.
on in there.
We've looked at this before.
Yes.
Let's color correct the Milky Way here. There we go. And now we're going to just do this over here. Look at that. Okay, yeah, I mean, you've got to pull this out, man. It's just beautiful. Remember, guys, you want to see this stuff, go to skytourlive.com, and that's the portal to enter and look at all the stuff we've done. Some of these images will be up there as well. Actually, all these images will be up there. Izabela says, wow, we made a full circle back to the nebula. Didn't we, though? This is really something.
That's really cool.
Yeah. Michael Klages, thank you for the suggestion. Now, there's also gas in here, so let's suppose a star formed inside this location here. This location might then become an H2 region, one of those red nebula that we see. And we'd see dark nebula mixed in with it, just like we do with the Orion Nebula. And that's pretty cool. But right now, there's nothing there. There's no stars that formed here yet. Wow.
I'm starting to see lots of lines of stars in there, too.
Yeah, you're sensitive to the star lines. Yep. You see more of those than I do, that's for sure. Let's see if we can contrast this a little bit. There's a subtle area right here.
Yep.
Beautiful area right here. Very, very nice. This is the ink spot, isn't it?
I believe so.
Yeah. It's B69. Very nice.
It's B74, just above that second star at the bottom.
Right. Yeah, it's B74, and we have LBN. Let me zoom in here. Okay, Lund's Dark Nebula 50, or B76, at the bottom of our view, underneath that star, probably it's right there. It's just heading out of view. And then B74 is this guy right here, as you mentioned, above that. Wow, look at this! Bam.
B70, B71, B73. A lot going on in there.
Yeah. Dean Bostador says 2-minute exposure. Actually, this is 50-second exposures stacked. So if we look at the stack, you can see our total minutes so far is a 5-minute exposure that we've taken basically 6 50-second exposures and stacked them. So they're really only 50-second exposures. But we could take a 2-minute exposure, but I don't want to make you guys sit through that. No, I mean, I don't know that we have to, if you notice this. I mean, it looks pretty nice. It makes me just want to, like, go down one field and do it all over again, and go up one field, do it all over again, you know, because there's so much going on. So this is the Snake Nebula right here. Okay, let's see if we can bring out that detail. What does it want to show us? Okay, so that's the detail level it wants to set. Now, all this dark nebula is composed of dark dust, right? Dust that's basically probably covered with ices that have CO2, carbon dioxide ice, formaldehyde, methanol, water ice on it, and it's either a silicate grain or it's a carbon molecule of multiple carbon atoms. Either way, those are the fundamental building blocks of the universe, and once the ice melts off of these from some nearby star, that becomes a slurry of material that's now available to make planets and other stars. And I think that's just amazing. Michael says, that's already as good as my 4-hour stack. Well, Michael, to be clear, we do have a superior site out there, don't we? So it does give us an advantage. But don't let that discourage you. Just think about getting some filters. I don't know, what do you have, Michael, for filters? We're using a filter called the UHC-S filter. I also have the radian filter, which is a narrowband slotted filter as well, but that's not in the system right now because I can't use a wheel. On the telescope out here, we're going to have a wheel that, as we did before, which allows us to shift between the filters. We can even do spectral filters as well, so we can actually see the spectra of the stars. But tell me what you got for this. Hey, GSEO. Yes, the snake is really getting black now. You're right. Part of that is my processing. If I come back in here and tell it to just, where does it want to go? It might go a little lighter. We can actually reduce the contrast a little bit, or increase, so you can see what else is here. There's a lot going on in here. So if I just give it this, now I can take this other histogram over here and pull out more detail with that, like this, and this will, it's a lot, I mean it's too much, but just to give you an idea of what's there, you can see all these blotches. This is just an amazing set of debris left over, because where it came from is from countless supernovae, where that had previously been red giant stars, red supergiants, and their outer atmospheres formed molecules of material because it was so far from the core that it was cool enough for that to happen. And the dust was also formed in a supernova explosion over time, as the cloud of gas and dust expanding outward cooled.
I think the cloud at the top, a little left of center, is interesting. Up the top, that one there, kind of a lens shaping. It looks different than the others. Now that you still looks sort of different. Got a little red in it, perhaps.
Yeah, I see what you're saying.
Kind of reddish cast to it.
Yeah.
Still, there's a ton of stars in that image too. Even where toward the lower left third of the image, a lot of stars sort of mixed with maybe fainter bits of the nebulosity. I don't know. It's a really cool picture.
You can see that some of the stars are very red, and those stars could be M-type stars, which are the small red ones. I call them the little percolators in the universe. But some of them are also embedded in this dust. And just like when we have volcanoes and they spew dust into the air, they make ultra-red sunsets.
Yeah.
That's because the dust is scattering that blue light even more efficiently than the molecules do normally. So we get much redder sunsets. That's right. Well, that's reddening, actually. No, it's called reddening. Extinction is something different. Extinction has to do with starlight that's diminished by passage through the atmosphere.
All right.
And then you have to correct for reddening and extinction. They're two separate corrections. When I was doing photometric work, I had to correct for extinction and I had to correct for reddening as well. And then you had to measure what that was, you know. But that was cool.
I see you're at 44% zoom. Could we kind of scroll down and to the left some?
Yeah, let me just zoom out a little bit more.
Okay.
Oh, look at that. Now I'm in the way. Let me move myself out of the way. Wow. Interesting stuff there.
Yeah. Excuse me just a moment, please.
Okay. So guys, what do you think? Is this was it worth it tonight or what? I think that's pretty cool tonight. Looks like a really nice night. We actually managed to squeeze out a good night tonight, huh? Yes, flying through space. Dun, 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 dun. I use that actually to point things out sometimes. Wow. Yeah, Michael Kliger says James Dugan, Baade makes really good filters. I'm using the Baade UHCS. That's the one I'm using. And I'm very happy with it. Yep. The radian filter is the one that's it's called a narrowband filter. It only allows in very small swatches of light, but the light you want. So you can't see through the filter unless you put a bright light behind it, or unless it's the light you want, you know. For example, the radian filter probably would not see this dark nebula very well, because this dark nebula here is not generating the kind of light that the radian filter would allow in. Shane, you're more than welcome. This is a very beautiful image, no doubt about it. You got it. So let's bring the telescope back here. I do want to show you one other thing. We've been looking at dark nebulae. We have captured 18 of these, and we just finished doing 18. So I'm going to pause this. This is the Snake Nebula. So I'm going to do that, and that's a DN, a dark nebula. And we're going to pause this, save the raw image to the database. Boom, it's on its way up. It'll be there in a second. And then save it exactly as seen. Okay, and don't worry, this isn't going to block it. You're going to get the full image. All right, you're not going to have anything blocking it. So I want to do one other thing now. I want to clear this, and I want to show you a different kind of nebula, because it's really important, I think, to show you where these things come from or what they can create. And that's what we're going to do. All right. So let's go back here. And I'm really trying to rush because I don't want to be caught by clouds and not be able to show you all the things I want to show you. All right. Yeah, we're already getting low here. Okay. So we're gonna go up here, and we're gonna go to this guy right here. This one may have a database issue too, but we can make it work. Telescope is now slewing to a bright star nearby. It may go to one of the stars here in Sagittarius. It did this one before. That might be the one that... Yeah, that's the guy that... Al Nozzle. And it's going to center Al Nozzle before it goes up to this other star. Or this other location. So we'll check it out. Alright. Welcome back, Daryl.
Yes, I am.
Yep. Okay.
I was muted because I was eating a cracker.
Oh, cracker. Alrighty. Alright, welcome to the Lagoon Nebula, the summer showcase item that I love to show people. And we're going to head to the east a little bit because I really want to show you this additional little area over here because they're linked together. Really beautiful. Okay, so that's good right there. Let me excuse me. Let me see what we've got for focus quotient. Make sure we're good. Oh, looks good. I think we're still good, Daryl.
Good.
Okay. All right, now to fully blow your minds, this is a 30. This is gonna be actually a 40-second exposure. This 40-second exposure will blow your minds if you haven't seen this before. And what I'm gonna do is, this is of course called the Lagoon Nebula, or Messier 8, and it is a BN, a bright nebula.
Oh, when you were in Stellarium a little bit ago,
Yeah.
and you mentioned the hourglass.
In the
It was the hourglass in the lagoon, of course.
yes.
Okay. It's late. I'm tired. I didn't put two and two together.
No, that's fine. That's fine. Okay. All right, check it out. Okay. All right, here we go. The system doesn't know what to do with the initial image, so you have to either wait for another one or you can give it a shot like this right here to show you what's going on. Look at this complex region of space. This is incredible. And the second image here, the second stacked image, you'll see a lot of this stuff is going to go away. Ready? Wow, there's a lot of noise. Ready? Watch this go away right here. It's going to get dark and more clear. Oh, look at that. Look at how beautiful this is. Oh, gosh. A beautiful star-forming region, the Lagoon Nebula. Once, the lagoon was just a dark nebula. And then when hot O stars, 30,000 degrees, well, 30,000 Kelvin in temperature formed there, it caused the hydrogen to ionize and cause this beautiful glow that we see. And the music is almost too perfect. It almost sounds like a angelic type music, and it is really pretty. And I wanted to show you this section too, because there's lots of tiny little dark globules in here that are going to make themselves evidenced shortly.
I was going to ask you about that area in particular.
Yeah.
The very bright red slash there of I wonder if that's being. It must be
You
a
see?
mission nebulosity. Yes, I wonder if that's coming from one or both of those two bright stars close together. Sort of
It
like
depends.
how Sigma
Yeah.
Orionis lights
Mhm.
up the Horsehead area.
Mhm. Well, Sigma Orionis and the Horsehead region are much closer to us than this region.
Yes.
So these could be relatively the same distance as Sigma Orionis and the Horsehead, relatively. I don't remember if it's. This might be what, 5,000 light years away.
Something like that.
Yeah. But you'll notice these beautiful dark swatches here. These dark splotches are areas where there is. If we zoom in here, look at this little hook, this Bach globule, These globules are in here. These are those areas that are gravitationally condensing, and gravity is condensing them, and that is amazing, just stunning. Look at this. Okay,
There was one just to the left of that brightest red spot, kind of a tendril shape directly above those two stars.
right here.
Yes. If you could zoom in on
That's
that
good.
more,
Yeah,
kind
okay.
of.
Right here, or is it
Sorta.
about this?
That one right there.
Yeah, look at that.
The dark is kind of delineating the left side of that bright red part, and it's
Yeah.
narrowing down to a little skinny tail right there toward the bottom right.
Right there, yeah.
Yeah.
Hey, where'd you go?
Whoops.
Okay. Yeah, it's back. Yeah, but you notice this cloud has more detail than we've ever seen. This actually is a modeled, basically dark nebula that's being scattering the blue light from these stars, causing it to
Yes.
look like this modeled view, which is
Exactly.
really phenomenal.
Yeah.
So I think that's really cool. And if we come out and just come down here, I like how we can zoom in with this system. We can zoom in just really quite unbelievably. We can zoom in to the point where we can just jump right in here, get right into this. Just get right in there, right up close and personal, and see this detail in here, inside this nebula. Just incredible. Look at this little hook right here. Look at that. With a star superimposed over it. Isn't that something? It's like the little baby dinosaur nebula. And then you see this dark spot here, and then you see that it has a tail on it. That's because there's a hot star somewhere in here that is causing that material to flow back over time. It's done that, and that's what really looks cool. Really cool.
Is the focus soft, or have you just zoomed in a lot?
I'm zoomed in quite a lot,
Okay.
but I always test the focus, so let's do that.
Well, don't let me distract you. I mean, I see now you're
I
just
can
zoomed in
see
a lot.
Yeah, but you know what? It could be that we need to change the focus as well. So what I'll do is I'll save this. I'm not gonna get rid of it. I'm gonna save it. All right, we'll save it just like we see it. It's had 10 frames that are stacked, and then we'll save it exactly as seen. Okay. All right, so now that's there. So we'll clear now. Come back here. Go to our 1 second here. Come in here. Give us a beautiful view, 1 second intervals. Okay, and now let's zoom in. Focus may still be good, but you know what? It's always helpful to try it again. could make this incredible view. So we're gonna drop focus out a little bit like that, and then we're gonna scan in. Okay. So guys, I want to thank you for joining us tonight. We're not done, so don't run away. We're just hanging out. We're gonna scan in now and build our new focus curve. We have 117 stars that we're using to do this right now, so we're actually getting quite a we're going to get quite a good focus. Now we're at 153 stars, so the focus is even better. The more stars, the better. And you can see our curve is building.
Strictly speaking,
I
mean, can you have too much of a good thing?
Well, it's going to average, right? And right now, I've got 12 steps, 12 focus locations, and I'm doing 3 samples per star location. So really, it's picking a lot more locations than just 12, and you know, it's doing basically 12 locations, 36 samples overall. And here is our focus. Our focus is good. The bottom of the curve has been found. So we can get rid of this now. And then I will turn on temperature compensation. And the temperature dropped by, actually didn't change at all. Alright, so now let's do this again. But now I'm going to actually do something else. The last one we did was, let's try actually a 60-second shot. Okay, so 60 seconds is underway. Alright, and we're going to get rid of this hybrid shot because that doesn't really help us. And then we'll go to our live stack. And one of the things that we'll see in the image is that area that's the brightest in the nebula is going to be totally blown out. But we can reduce it. We can bring it down pretty low so you can actually see what's going on in there. Brandon Manis, how are you? Brandon, explain the comment. Time emit equals emissions in time. Love to know what you mean by that. Okay, so now we're going to get rid of this brightness here. Look at that. Okay, so now we're going to just do some processing here. Yeah, and now we'll back out to the full screen so you can see what's going on here. Wow, now you can see all this additional stuff in here. See that? It was not really as visible. And now it is. Now it is. And we can also see part of the Milky Way down here. Everything you see in here, all this dark, it's not gaps. It's dark nebula. Dark nebula. Made very clear when we zoom in, say here. Okay, you can see that this dark nebula is encroaching on the nebula that's lit up by the very, very hot O star, which is illuminating much of this nebula.
And the hourglass we mentioned earlier is right in the middle of that brightest part, correct?
Yep, and if I can take advantage of something that this system can do, I might be able to show you that. If we drop this midpoint value down really, really low, okay, Yeah, it's just a little too saturated, but it's right in there is where the O star is.
Yeah.
And that O star is extremely hot, and it's ionizing the gas in the nebula actually quite easily. So we've done 2 frames so far, and as we move along here, you can see there's Reflection Nebula here. There's more over here. We saw that before. We see Dark Nebula. We see Bach globules. Okay, the dark globules. That was, and you see them there.
JSCO asked a minute ago, carry on. He was wanting to look at that red area again, and he was that, and he said it's almost pointing at that smaller, very bright red area down to its lower right.
This here?
Yes.
Okay.
I think that's really pretty. Boy,
It is.
The reflection nebulosity around those stars and the big red slash, and there's like a bright line running through the middle of the red slash. That right there. Some stars are in it too,
Yeah.
or at least in front of it, and then that smaller red thing right there.
Yeah.
And then
This
all
is a
the
whole
dark.
complex.
Oh yeah, then all the dark stuff working its way across it.
Yeah, look at this. It just goes this way, and then it comes down here and snakes around. It goes up and over and around, and it's a snaky line, all part of the same origins, probably. And then we come over here, and we see over here, we see this beautiful reflection nebula. These are called reflection nebulae, but the truth is, they're scattering nebulas. In a sense, the stars are taking in the blue light and sending it out in all kinds of directions. And so that's where the term reflection comes from, but it's really a scattering nebula. It's scattering the blue light and allowing the rest of the light to go unimpeded. Because the blue light is the highest energy, and highest energy affects molecules and atoms. So that's why it gets scattered. Look at this stuff, man. I think I have a little guiding error going on here. Oh, it's okay. I'll take a few more shots of this. Look at how incredible. It's like it's almost 3D how this looks now.
Yeah.
See, it almost looks 3D. Wow. Look at this. Way at the top. The subtle edge of a dark nebula. Look at that. Soft edge shadow caused by the light. Oh, that's beautiful.
See a little blue in it too.
Yeah.
Is that at the very top of the frame?
Yeah. I can't go any higher.
Yeah.
I could have brought this all down a little bit, I guess. And put this out of the view, which I want to keep it in the view, but... Well, let's see. We did 6, right? So let's save it. I'll pause it. Actually, no. I'll resume. I want to catch that last one. Okay, you got 7. So now I'll pause it, save it, and save it again exactly as seen. Now I'm going to clear it. And you might say, why? I'll show you why. You're going to like this. Alright, now we're going to go back to our 1 second view, and Now we're going to take this and we're going to go like this. We're going to head north. Right? We'll do this. Okay, because we got more up here now. Alright. And that looks like that should be pretty good. Now we're going to do the same thing. We're going to come back and do the same exact shot here. We did 60 seconds, right? So we're going to do 60 seconds here. We're guiding, as you can see. It says searching, but it already been guiding, so. And we'll do our live stack now. And we'll see what's up above. And then we'll turn that into a mosaic later. 5 frames, 5 minutes. Michael Klages says, I've spent more money on filters than I have on my telescope. Yeah, that is a true statement. I have one filter that we use which cost over $1,000. A little piece of 2-inch diameter glass, over $1,000. But the results make any telescope worth less a superstar performer. Okay, let's get this first image. What do we got? Oh yeah, there's quite a lot up there, Daryl.
Are you still
So
hyper
this is
there?
a shot. Yeah, this is a shot showing everything that's there. Okay, so if we remove that, okay, and then we come up into our stack, we can see that beautiful, subtle, ashen color up there. It's really something. This is the beautiful lagoon complex that I think is the best image. Really the best. Okay, we've got one stacked with the second one coming in. You'll see it gets better almost immediately. Yeah. Okay. Look at that, just that beautiful subtlety right there. This area right here is stunning. Look at that. A blue-edged cloud.
Uh-huh.
A dark nebula. Wow.
Colors look a little more subdued now.
Well, let's see if the color correction is in order.
The red's a little more muted.
Maybe. That could also be due to needing to do what you're about to see me do now. Maybe like that.
Yeah.
Wow, look at that. That is really nice. Now, just so you guys know, and you probably, some of you do, this is really an area of the universe in space where you would not survive very well. There's too much ultraviolet radiation. You know? Island Warrior, how are you? Am I the only one, he says, am I the only one that feels that the JWST will be discovering something amazing in the next few months? Absolutely not. I actually said earlier tonight that I think the James Webb Space Telescope is probably going to discover life on other worlds. It has the capability to see things like industrial pollutants. It can infer oxygen in an atmosphere. Can't see it directly, but it can infer it because when oxygen atoms collide, they leave an infrared signature behind that will tell you how much oxygen is colliding. It's unmistakable, and it can't be mistaken. So
I know they saw water
yeah.
in the atmosphere of that exoplanet they looked at.
Yep.
A spectrograph image, I guess.
Yes. That's right. Hey, Fantasy, how you doing? Good to see you. Uberku, what's going on? Uberku says, I hope either JWST or W First can scan an exoplanet for its special signature. Maybe one day we can find natural non-industrial chemicals. We can sort of do that now. It's really kind of cool. So, but it's the telescope has the ability to see a great many elements that live in the infrared, and the signatures of elements that are in the infrared. My God, look at this! Holy cow! This is so stunning.
Yeah.
Wow. Soulborn, I don't know what that was supposed to mean, but those kind of comments get you, made invisible by the moderators.
Yeah, he just did. Rule 34. You don't know what Rule 34 is?
Rule 34? Is that what he said?
Yes.
Okay. I just saw a string of like the same characters. I didn't see what it said.
It's very naughty.
Okay. Well then, there he is.
I'll leave it to you to look it up at your leisure.
No worries.
I do have a funny picture for it though. You could probably get away with showing that if you wanted to share it. I'll
Not
leave it up to
necessarily.
It's not. Huh?
You can send me the picture.
All right. Give me just a second.
Does it have to do with Power Rangers?
No, but it's got Japanese monsters in it.
Okay. I don't know why I'm so intrigued by this section here of the Lagoon Nebula. Look at this. This encroaching dark nebula here. This is really pretty. This is 8 stacked frames. The guiding is pretty good.
There you go. No exceptions.
No exceptions.
What part were you talking about?
This right here.
Oh yeah, I like the whole thing.
Just so impressed with this. Oh, Vera, her battery's going down. I'm sorry. We'll stay safe. Thank you. Hey, black man, what's happening? This whole dark nebula here is fringing this entire element here. Thank you, Vera. You too. We'll see you again soon. Wow. I don't know. I'm finding this to be so incredibly impressive. Look at it. Okay. Look at this right here. This is really an impressive wake, you know, that's created by a star that's actually probably blowing this material down, you know. Wow. Wow. Okay. Well, this is, we are at 10, so we're gonna pause. We're gonna save this now. I think we're still at M8. We are.
Blackman asks, do we have the rough coordinates of where you are viewing?
Yeah, I'll show you right now, Blackman. 1 second. Okay,
just above the tip of the spout of the teapot in Sagittarius.
Yeah, but I'll do better than that. I'll show them exactly where that is. Okay, so here's the teapot of Sagittarius. This is Sagittarius the Archer. Okay, right there. And classically, the bow and the arrow are here. Okay, but right above that area is the Lagoon Nebula. That's what we're looking. And this is part of the entire summer Milky Way. Okay. And I haven't gone up north to the North American Nebula yet.
Well, you ought to try this.
Try that?
You ought to. I'm going to have to leave pretty quick. What you do the Trifid real quick.
Oh, Trifid, yeah, the Trifid's beautiful, yeah.
Trifid is just above the lagoon.
That's correct. All right, so let's take ourselves back to here. Might as well do it because it's actually sinking into the southwest.
Yeah.
All right. So let's do that. So let's see now. Okay, so that's set. So I can save that. So now we're going to go to the Trifid. Yeah, we'll do our 1 second shot here. Look how beautiful that nebula is, even in 1 second shots.
Cosmic ray. How does one know what star is illuminating what gas? Typically, they look for the hottest, brightest stars, O-class, B-class stars. And as Marc mentioned earlier, there in the middle of the Lagoon Nebula, there's an O-class star. Very big, very hot, very bright. That's is very energetic, so it's causing all the gas around it to fluoresce or release emission in hydrogen alpha in this case.
That is well spoken.
We talked about the Horsehead Nebula earlier, and it's being illuminated by a Sigma Orionis. That's the big, hot, bright star, actually a multiple star system. That it's the biggest, hottest, brightest one in that area that's causing the emission there. And one of my favorites.
Okay.
Black Man, what website?
Oh, I think he's talking about ours. You want to go to the right over my head there, Black Man, skytourlive.com. And that takes you to our portal, which takes you to all this data, takes you to a gallery of the images, takes you to the stream. Yeah. Okay. Excuse me.
SkyTourLive.com.
Yeah, skytourlive.com or skytourlive.org. The org owns that too. All right. And now we're going to bring this down and then get ourselves centered up.
Gee, 1 second exposure and you see color already.
I know. There you go. Okay, so we're gonna search and we're gonna set up a 45-second exposure here. That's all we need for the Trifid. It's actually got a lot of detail that can be brought out in 30 seconds, never mind 45. And we are guiding, as you can see. So here we go. And we're going to remove our hyper view here, go into our stack, clear the previous stack, which is this beautiful image, which is going to be up on our website with no problem in no time. All right, so 45 seconds of the Trifid Nebula. Classic nebula, it's an H2 region with a dark nebula, a set of lanes. H2 meaning a star-forming region, a stellar nursery, and a location where there's lots of dust that's being that's scattering the blue starlight, and that's why it looks like what you're about to see. Okay, now we just do a little processing here on this single frame. And you can see there's a lot going on in here. It looks really beautiful.
Yeah.
Let's move in a little closer.
The Trifid is Messier 20. It sits just above Messier 8, the Lagoon, and they're both just above the spout of the teapot, and this is where the Messier objects kind of march up along the Milky Way, heading toward the northeast, I guess, along the Milky Way. You'll see a whole chain of Messier objects going along with the Milky Way.
Hey, Ben Zavala, how you doing? Thanks for dropping by. You got here just in time to see the Trifid Nebula. Right there, it looks beautiful. Trifid's interesting, and I wanted to show you this. You notice these three dark lanes here. This is why it's called the Trifid Nebula, and this is that stellar nursery region here that we're seeing. But if you look up here, this area right here is a blue area of reflection nebula or scattered light nebula from the star here that's scattering rather there's dust here that's scattering the light, the blue light from the stars here. This is one of those areas, okay, where we see what might have been a dark nebula, and the only reason we see it as blue is because it's scattering that star's blue light, right? And for it to be so close to a red nebula like this is interesting because it shows that there's not a lot of gas in here, but there's gas in here. So it's like this whole region formed as a spherical pocket almost, potentially, of hydrogen gas, and then this may be further behind it, okay, and this might be up close and that might be behind it, or vice versa, not sure. So they might actually be physically distant from each other and not actually attached to each other. They might be one behind the other, so that could explain why this might be illuminated but this is not. But just incredible.
I would wonder. I would wonder if the blue portion is being illuminated by that star right there toward the lower part of the blue, or by that bright star to the upper right.
Or that one?
Yeah.
I don't know. But if you notice, it's possible, if it's not a line of sight thing, that this star could be having its light scattered. But this star is definitely bluer than this star, so you have to wonder. And there might be a paper out there that somebody must have done this study. You know?
Yeah. And as far as the red part goes, I'd have to think that brightest area of the star in there is probably illuminating that part.
Yeah. This is an emission nebula, EN, and a reflection nebula, RN. So this will be up there. We've done 6 of these stacked so far.
It's very pretty.
Yeah, the thing that I like about the Trifid is that when you do deeper shots like this, you can see how the blue extends all the way around this nebula. So it's like this is a pocket inside or in front of the nebula. Not sure.
Yes.
And I find it to be fascinating. What do you guys think? Oh, goodness. And very much, there's a lot of detail in here. I might have turned off the Unsharp masking. I did. Okay, it's still on. Okay, good. I turn it off. See the difference right away? Unsharp masking does things with color that you may not like. And in this case, it will brighten up the colors because of the way it operates. But that is more of what the nebula really looks like.
I'm seeing more blue around the sides and even to the bottom than I have in the past, as you pointed out a minute ago.
Yeah, I think it's just fantastic how that looks.
It's like the whole thing is actually wreathed in the blue part.
Yeah, it does look it. It could also be that there might be gas out here, but it's too far from the star for the star to ionize the gas, which explains the spherical shape here. Because the ionization occurs out to a certain distance and then it can't do anymore, but it can still scatter. The particles of dust can still scatter the starlight. So that's possible. And James Dugan says something that I've often thought of, actually. You look at this, and it looks like you're looking at the eye doctor's retinal scan. That is what it looks like. Absolutely. Wow. Okay, I'm going to pull out now for a minute and just show you the overall field. You'll notice that we have star clouds nearby. We have Milky Way, diffuse emission nebula, okay, a cluster. So a very active region of the Milky Way right here. Just beautiful. Let's zoom in and be crazy here. Let's just crazily zoom in here. Wow, that's pretty. These amazing little filamentary structures, those are just beautiful.
Wow. The most massive star that is formed in this region is HD 164492A and 07.53 Roman numeral 3 star with a mass of more than 20 times the mass of the Sun. The star is surrounded by a cluster of approximately 3,100 young stars. Would Stellarium show the name of that brightest star there?
I'm looking now. This one here?
That one or
this star? The one below? This is a B65. What's the star? HN40. It's a double star. It doesn't say.
check the big one that's to the upper right of the nebula.
This one?
Yeah.
That's the one I just clicked on.
Okay. Doesn't give a
It
name.
says no. It does have a name though. There's no doubt.
Or the other one that's up at the very top right. The one I wanted earlier. The looks like the biggest one. That one. Okay, that's not it either.
Okay.
Oh well. One of those stars is lighting it up.
Well,
HD 164492A.
I imagine that it's in here, and we just don't have, because the spherical illumination, that looks like an ionization radius.
Yeah.
You know, happening out to a certain amount. Well, okay. All right, what do we got here? I got that there. Live stacking. What do we got? We've got 14 stacked. We'll go to 15. And then we will stop.
Yeah, I'm gonna have to call it a night, Mark.
Okay.
It's past my bedtime. Been a ton of fun. Been a fun stream.
Yeah. Yes.
And,
I'm gonna pause this.
You know.
All right. All right. Well, very good, Darrow. Thank you for coming along.
Oh sure.
And let me figure out now. Let's see what we've got. Let's see if we've got to make any changes here to our let's check out the view with the all sky. See if we still have a good sky for us, or if clouds are moving in yet. Oh, look at that, guys. Nothing. It's some out there. You can see them. Nice. All right. Very good. All right. So now we're going to come back and do our 1 second here. Really beautiful.
Okay.
All
Well,
right,
carry on, Mark.
I will.
And,
Thanks, man.
Been a ton of fun, and good night, everybody. Take care and have fun. We'll see you soon, hopefully.
Hey, they will.
All right.
Okay, we're going to probably just do one or two more objects.
Okay. Good night, all.
All right. Good night, Darryl. Thank you.
Good night.
Bye. All right, guys. So let's go on and try something different. Okay, we're gonna look for, there's so many things to look for. Oh my gosh. Oh, fantasy. You had multiple people watching? That's fantastic. Okay, let's go up to do one thing. There's one more nebula that I've gotta see tonight. I've gotta do it. And I think that it's really important that it's going to be right up here. And it's going to be the North American and the Pelican. Tons and tons of things up here. There we are. All right. So the Pelican Nebula is a incredible area, and we're going to check it out. I hope. Let's see here. We're going to go right now. Okay, off we go. Here we go. Telescope's going to head over the back side and look. You can see where it's looking right now. It's kind of looking that way. And we're going to be going to probably Deneb right here in order to find it. And Deneb is the tail of the swan in Cygnus the Swan. Okay, and there we are. So we should see Deneb in here. There it is. It'll center it. And then it's going to pull us into the North America Nebula. Very nice. And there's the nebula. Can't miss it. Look at that. Stunning nebula, as you're about to see. Much to see here. Let's move up. Okay, so this is the Gulf of Mexico in the North American Nebula. This is Florida, and this is the United States in this nebula. Okay, and Pelican is here, and you can see this beautiful, this is actually called the wall, the Cygnus wall. And when you see this, you're gonna go, wow, really, really something. So this is pretty good right here. So we'll wait for our system to lock on, and then we will take a 45-second shot. Okay, we're guiding. You can even see detail already. Oh, it's going to be something special. Here we go. Okay, 45-second shot. Take our live stack and just wait for the most amazing results. So we're at 19 seconds down, 22 seconds down. North America is a big nebula, Izabela says, and it is. Okay, we have 9 seconds, 8 seconds, down to 5 seconds now, waiting for this to come up. And it doesn't look like much right now because we have to process and get a quick processing done. But that's what we're going to do. You ready? Watch this. Kabam! Wow. Kabam. That's incredible. How pretty. How beautiful it is. Now we have two stacked. Look at the detail in this already. Oh my gosh, this is by far the most beautiful thing I've seen. Look at that. Wow. I'm going to zoom in on this part right here just to see this. This is the wall that we're talking about. This very fine material that you see here. This beautiful cloud here. I've never had this kind of detail in it. This is really stunning for tonight. Look at this. So you see tons of dark nebula. And it leads over to the Pelican Nebula, which is here. Okay, and we're actually zoomed quite a bit. Outstanding. 3 stacked. Hey guys, make sure you give a thumbs up, will you? Because keep us going. Help keep us moving. This is the Pelican, actually. That's why it's called the Pelican. Rubriku says that red stretch looks like a bird. I think that's what you mean, right? This red stretch. That is a bird. It's a pelican in the vernacular. We call it the Pelican Nebula. What you're actually seeing is this nebula and this nebula are actually one and the same. They're kind of together. But this dark nebula is like here, blocking the nebula behind. So that's how you look at this. This isn't a void in space. This is black, dark dust that is actually blocking the nebula behind it. Oh, you're talking about the left of the screen over here, Rubriku. Oh, you're talking about maybe this stuff here. Okay. Oh, Benjamin, no problem. This is just beautiful. We're having fun. Look at this gorgeous element right here. Look at how beautiful this is. Look at these very intricate locations. You know? Cosmic Ray says, without knowing the distances of stars and gases, you don't know what is what. Stop blowing smoke. Is that directed at me? Because if it is, I hate to tell you, but I do know the distances of everything I'm looking at in the image, and I do know about the studies that were done on the North American Nebula, and I do know where things lie in a relative three-dimensional point of view. So if that was directed at me, then I respectfully submit that you're not correct. I do know where things are. But I'm sure you'll tell me. Look at this beautiful area. This is, like I said, this is called the Wall. It's a beautiful location. Let's zoom out so you can see this overall. Fill the frame. There you go. Look at that. Wow. So as I said, this is the dark nebula that is obscuring the bright nebula behind it. We see this all over the universe, and we can measure distances to these objects, and so I don't speak from anything but a factual basis. Let's see, we've got 8 stacked. We'll do a couple more stacked images. And we talk about stacks for those that that may not know. We take an image, then we take a second image, and we align it with the first and put it on top. And we do that over and over and over and make a sandwich of images. Now, what that does is it takes the noise that occurs in between all the stars, okay? When you zoom way in, this is the noise, the stuff that you see in here. And what it does is it averages out all that noise, you know? Averages out all that noise. And so you end up seeing the data that is actually preserved. So it's pretty cool. Oh, thanks, Jessica. That's kind to say. Thank you very much. Yeah. The grainy stuff is the noise, yeah. So isn't this a beautiful nebula? It really is. This nebula is approximately 1,500 light years from us. The dark nebula is just a little bit closer. JSCO 77, thank you. Your point is, of course, well taken. If you notice this now that we've stacked some more, isn't it interesting how you can almost see this almost looks three-dimensional? And that's truly just a speculative thing, but it almost looks three-dimensional, doesn't it? Really, really cool. Let's try and do a little more processing to draw out some of the details here. Let's take it where it wants to go, and then let's push it where I want it to go. Okay. All right, so now when you push, you can see all the intricacies in this dark nebula here. Lots of intricate details in there. Isn't that cool? You know, and then let it go back to where it wants to go. And now if we were to pull this back a little bit, just pull that dark level back just a little. And then pull this guy in. This is called a push. And then we pull this back in. The closer we bring these lines, the more noise we're going to see introduced into the image. But we don't want perfectly 100% black. We want something like that. Is that not beautiful? Ah, that's really something. Okay, we stacked 13. We're going to go to 14. Look at this. Look at this. Holy cow. All these, look at these details. Ah, this is, it's actually unprecedented detail that we're seeing tonight, guys. You're seeing it here with me for the first time. It's unprecedented detail that we're seeing. It's beautiful. Okay, so I'm going to, this will be the North America and Pelican Nebulae. Okay, and we'll go to 15 and then pause. Look at this, jeez, and pause it. The more you stack, the clearer the image gets. So now we're going to pause it, we're going to save it. Boom, our raw data is saved, and saving it exactly as seen is done. Yeehaw! Good deal. Okay, so that's good. And now we're gonna head to the next image, which is going to be just a little further down. And it's an image of something that you just can't look at and not marvel at. Okay, so we're gonna go there in a sec. I'm gonna go to my 1 second now and bring up our metered view here, a nice highlighted view. All right. Okay. You're gonna like this. Okay. This object I'm about to show you is the remnant of a massive supernova. And it's got so much color in it that you're gonna be astonished if you haven't seen this before. So here we go. We're probably going to go to this star, or maybe just going to go to that star as a waypoint star. Here we go. So there's the waypoint star. And then you'll watch this object come in. It's going to center this up, which is doing it now. And then it's going to bring the remnant of this star that obliterated itself in to the frame. Izabela says the colors are very special today. Yeah, they are. Okay, look at this about to come in now. Watch. Wow. That is one side of the supernova remnant right there. Okay, and what we're going to do is we're going to move that up a little bit, because there's more down here to see. Trust me, I know. Yeah, Michael Klages says the structure of this nebula is amazing. It really is. Remember, we're seeing things in 3 dimensions. So, obviously, the nebula could be swinging around in the distance, coming toward us, going away from us, because the universe is in 3D. And you have to keep that in mind when you look at these things. All right? So, we're guiding now, and we're going to do a 25-second shot of this. All right? And so we're going to get rid of our hyper view. And our 25-second shot will reveal some really interesting stuff. Michael Klages says it looks like a DNA helix, this particular site. As you'll see, he's correct. Watch. It's in a region of vast amounts of stars, has beautiful colors. These colors are caused by when the supernova went off. The greens are actually oxygen 3, which is doubly ionized oxygen. The reds are hydrogen and other elements like neon and so forth. But man, you'll see there's also subtle other pieces in here, because this is called the Western Veil segment. This is the Central Veil segment. And then on the other side, around where the telescope control is is the eastern veil segment, which is by far the very most beautiful. Benjamin, this is the Veil Nebula. That's why it reminds you of it. That's pretty cool. Okay, so let's zoom in a little bit. Look at that. This star is called 51 Cygni. It has nothing to do with this nebula. Yeah, and Michael Klager says, if we could get a telescope to the edge of the solar system, we could create some 3D measurements. That's correct. That's correct, because it's actually not that far away. It's close enough that we might be able to do a parallax measurement. I worked in parallax programs in astronomy. That's actually was my main job. Actually, I was actually doing parallax measurements of stars. You see that? There's more of the nebula here. Really awesome. Let's see if there's any processing that'll help us here. Coloring. That's a little better, actually. There you go. We'll go to 7 on this stack. All right. And then we'll pause it and we'll save it. But first I got to name it. So in that case, let me not pause it. Keep it getting data while we go. Okay. Veil. Veil. Hey. And it's an SN, a supernova remnant. Actually, SNR, supernova remnant. Okay. And it'll be... Alright, I'll go to 10. I'll go to 10. I do a lot of processing in Photoshop. And when I do the processing in Photoshop, I will actually reduce the brightness of the stars compared to the nebula. And I can actually remove the stars entirely and show just what the nebula looks like without stars. And that's very helpful. Okay. There's 10. So we're going to pause it. And now we've got it named. Save it. And then save it exactly as seen. Okay. Now that it's done, we're going to clear it. And you'll see it up on the data file in the database. Okay, and now... It's amazing what's hidden in the universe, huh? You just see a few stars, and then you do this, and it's like, wait, what's that thing? And it's amazing. And now, just to show you something else, I'm going to take us now to the east. And watch this. Move over to the east now, and there's something else of interest here. I gotta check, make sure I didn't go too far. No, I didn't go too far. I'm fine. Okay. So now we go up a little bit. And let's go into our mode here. Fill the frame. And now we've got this. This is the other half. well, it's two sides, right? And then there's a central part, and some of it's near us, some of it's further away, because it's a spherical expanding cloud of debris. And what we're looking at here might actually be something that looks like this. It might be a shell that's expanding outward. We know it's expanding outward because we can measure, we have. But let me actually just, that's too far. I didn't want to do it that far. Let me just go down here, bring this back up now. Like that. There we go. Okay, and then I'm going to move us a little bit more toward the west. There's a reason for that, because I want to show you where the central veil will be. There's some other stuff in here that we might be able to pick up. Okay, so first things first, let me go to 100% and check out the stars. They look beautiful. That's good. So the stars are indeed focused. All right. Now, we're going to do the same thing here. We're going to do a 35-second exposure. And you're going to see some beautiful colors. If you thought the other one was pretty. Wait till you see this. S'mores are good. Don't choke on your s'more now when you're about to see this image. This is beautiful. Look at that. And there's that central part I promised you. Look at that. Wow. That's amazing. Wow. That's incredible. That's beautiful. Look at the sheer number of stars. The sheer number of stars here is stupendous. And the amount of detail in here. Again, this bluish green, that's doubly ionized oxygen. The red is hydrogen gas that's been ionized. But it's been ionized by several factors. It's been ionized by the initial explosion. It's also been ionized by collisions with the interstellar medium. It heated it up tremendously as well. There's a lot of interesting stuff. Yes, Michael Klages says, should be able to stitch these two together. I should, but I haven't done a whole panorama of this area yet, and I won't do it tonight. But it is a great option, and I do have a beautiful program that'll stitch stellar panoramas together. And it's actually a program that was made by Microsoft and then discontinued, but I have it, and I'll tell you what it is. It's called Image Composite Editor, ICE. Cosmic Ray says, oh, his message was retracted. Okay, never mind. I was going to try to answer your question for you. This is beautiful. Look at this. This is only a stack of 4. Let's go up here and check this out. Take a ride to this nebula. Look at that. Wow. That's the central veil right here. Amazing. Just amazing what's waiting out there to be found. Carl Sagan said it best. Somewhere out there are a wonderful thing is waiting to be known. Or an amazing discovery is waiting to be known. We're going to go to 10 on this one. Izabela says she stitched them once manually. Uberku says beautiful detail. Isn't it, though? I mean, look at this little guy right here. Look at this. These tendrils right down here. And the more we stack, the better they look. Let me see what I've got going on here. Did I, okay, if we turn off the Unsharp Mask. Okay, and turn it on. The Unsharp Mask also works on the stars, which we don't necessarily want. Okay, but if I turn it off, now you can see a little better what it might look like. Wow. Sorry, I'm yawning. It's like when you get a good night like this, you just don't want to stop. You just don't want to stop. I was up all day too, that's the thing. As an astronomer, I had to spend a lot of time sleeping during the day. Especially when I was working in the observatory doing the parallax program stuff. Not my observatory, the professional observatory at the university where I got my degree in astronomy. Alright, so alright. Let's see what we got. There's 10. I'll go to 11. Might as well. Can't hurt. One extra. There we go. And this will be now Veil East. Supernova remnant. Okay. So we'll save it. And we'll save it exactly as seen. Very good. Alright, now we'll get rid of this. Wow. Alright. What do I want to do? Oh. Tell you one thing I want to do is I want to start here. And then go here. So you can see how subtle this object is. You know? But when you take pictures of it like this, like we're doing, it's just stunning color. Shane, I actually worked at an observatory called Van Vleck Observatory in Middletown, Connecticut. In the parallax program, I actually captured images of stars, and then we used a machine at Yale to determine the distances based on these discrete measurements on the star plates. If you take a picture on one side of the Earth's orbit and a picture on the other side of the Earth's orbit, you can see how it's like two eyes, right? If you hold your finger out at arm's length, and you blink your eyes, you'll see your finger dances in front of the more distant wall. Well, that distance that it dances is called the parallax angle. And that parallax angle, once known, can give you the distance to that finger, or in the case of the stars. Really cool. So that's how parallax works. Okay. Excuse me. All right, I'm gonna look at another object here. This was a good get to get this Veil Nebula. All right. We'll go here and check it out. My voice is about giving up, as you can tell. Now, for those that don't know, I'm just getting over COVID too, so go figure. I'm not contagious. I actually tested negative now multiple times, so, but the cough sticks around for a while. All right, there is our star. We're centering Albireo. Albireo is a cool star. This is a double star. It's an orange star and a blue star. An orange K star and a blue B star. And they are just a stunning pair. There you can see the colors right there. You can see the colors in the streaks. And this is going to be a stunning photo. If you look where the telescope's pointing over my head there, it's pointing almost straight up. So this will be the prettiest possible image we could get of this guy. So we're going to center it up. Alright, and do this, and let's go north, and then go a little west. Sorry, I went the wrong way. Alright. This is not a supernova remnant. It's also a dead star remnant, but it's a remnant of a star that's less massive than the stars that make supernovae. When a supernova goes off, it just blows the star up to smithereens. But a planetary nebula, or this type of stellar demise, is done by a star that uses up all its hydrogen and expands and it becomes a red giant, and then it begins to use up all the material there, and once it uses up the helium, it does hydrogen into helium, then helium goes into carbon, and the star will expand. Then when it starts using up all that material, the star shrinks again, and that brings material down toward the core again, and you can get another spate of hydrogen gas fusion going on as it's brought closer into the core, and the star will pulsate, for several hundred thousands of years as a red giant. Well, as it pulsates, it'll puff off outer layers that are so far away from the star that they just continue to go away from the star, and that makes these shells that we see here in this image. All right, so let's there goes a Starlink satellite. Let's do this. Let's do a 25-second shot. All right, and remove our hypering. Izabela says I can just take a moment to get my voice a rest. Thank you, Izabela. So I shall do that. Wow. Oop. I wasn't supposed to say it. Sorry. beautiful, beautiful. Okay. Let's zoom in. Okay. Couple things to notice here, and I'll show it better when I do some manual processing here. But as I pull this down, okay, it gets a little dimmer, but what you also see is this central star. That central star in there is a white dwarf. That white dwarf is all that's left of the original star. The outer layers were blown off, as I talked about, in a variety of ways. So again, the bluish green, that's doubly ionized oxygen. The red is hydrogen gas that's now ionized. And I think that this is something that is really, really cool. And let's zoom in some more. Now you can really see it. There's that central star. Notice the color of that central star. Can you see that? Okay. That central star is blue, isn't it? Relative to the other stars that you see. This is actually quite blue. The reason is it's quite hot. The star is a white dwarf. And a white dwarf is about the size of the planet Earth. This is thousands of light years away, and you can see the white dwarf the size of the Earth because it's so bright. And because of that brightness and the fact that it's giving off a lot of radiation in the ultraviolet, because of that intense surface temperature they have, it ionizes this gas that was blown off the star. And so we see planetary nebulae like this. This is very common to see. Isn't that beautiful? Now we've stacked 6 objects already here. Looks really pretty. So let's I'm at 175% too, so let's go down to say 100%. Okay, so that's 100%. That's the native size, and it goes over this side and this side quite a lot if we're not fitting it to the screen. All right, so there we go. So let me show you what else is in here. All right, and to do that we have to get rid of that central star by just blowing it out. But check this out. Do you see that additional green? That shows you that there's a lot more stuff outside that was expelled from the star earlier. Is that not cool or what? That is just the coolest thing. Yep. But this is a planetary nebula, so named. These are so named because they look like planets in a small telescope. And when they were first discovered, they kind of look like planets. And so the fact is, at the time, they didn't really know that this was a dying star, or a star that had already long since stopped having nuclear fusion processes. White dwarfs don't do nuclear fusion anymore. They're just hot remnants. The surface is mostly carbon and oxygen atoms on these white dwarfs. You know, and this will eventually become what's called a black dwarf. It's going to end up just getting cooler and cooler and cooler and cooler. Yep. JSCO says, planetary nebulae are some of the most interesting objects to me. Yeah, as they are to me too. Yep. And Shane says, it will expand over time. Yes, it has been. And those clouds, that shell is slowly expanding. And guess what? There'll be a point where the shell will expand further than the white dwarf can ionize the gas. So what might be the glowing outer reaches, like out here in this nebula, all right, will eventually, those will pass through that ionization potential location, and then they won't be ionized anymore. That's part of the problem with trying to figure out distances to these, because We know that the white dwarf can ionize out to a certain distance, right? But we know that that's the case, but we don't know how big these things are because some of that gas may be already outside the ionization envelope, and so it could be a lot bigger in size than we realize, you know. So that's part of the problem. But they're notoriously hard to gauge distance to in general, so that's part of the problem we have with these. But it's very cool, nonetheless. Okay, we've stacked 14. I'm going to go to 15. Izabela says it's bleeding like it's stabbed. Yeah, that's an odd shape. And it looks, in some of the literature, it says this was the equatorial region of the star. And it was doing this, spinning. And thus, it created this apple core shape. Now, it looks sort of roundish, but in reality, if we actually... Oh, sorry. I removed it. Sorry. If we actually come in here and we take this black level and move it inward, you can see we can get through some of the different shapes in the nebula. Okay. So we come in. Alright. And then you actually end up seeing what it looks like in a small telescope, which is kind of like this. And we immediately get rid of, you take it like this and you can see that it would look like that in a small telescope. Notice how it sort of looks like an apple core. That accounts for its name. Some people call it an apple core nebula. But it has an official name. It's called Messier 27, and that's not changing. And this is also because it has this lobed structure where it looks like it has these lobes at each end, okay, like the apple core. This is called a bipolar nebula. And bipolar nebulae are common in the planetary arena. So I just thought you'd be interested in that. So let's go back to process that. All right. And let's bring this down a little bit so you can see some details. Well, there we go. That's, you know, that's the coolest little nebula there is. All right, and we just stacked 20 of them, and we're going to pause this, and but not before I name it. So this is Messier 27 Dumbbell. And it's a PN, or a planetary nebula. There it is. Now I can save it. Oh, and by the way, you see bright things flying through that. Those are bugs flying in front of the infrared camera in the building. Okay, so now we'll pause. After 22 exposures, there we are. Pause, save. Data is saved. Save exactly as seen. And there we go. Clear. And 1 second. Exposure, and then give us our hypered view. There we go. So that's a 1 second exposure. You can see the noise changing, but the stars and everything else stay the same. Okay. I think that this gives us a good overview of the summer sky. And we will eventually be looking more into the north as well. Okay, let me see here. I don't want to do that. I want to come down here. We're a little low now in the southwest with the Milky Way there. But one thing we can look at really quick is another object that is just loads of fun to stare at. Alright, and we're going to go there now. This is the small Sagittarius star cloud. You'll notice the telescope is spinning around like crazy right now because the star cloud is on the opposite side of the sky. It's going to one of the stars in Sagittarius here. And it's going to center it up, which is right there. Remember, we're at 100% on our sensor. So I'm going to drop that down to auto so it'll be a little bit more obvious. There we go. Okay, and then we're going to move up to this star cloud. And it's just a beautiful star cloud. Go. Okay, so now what we're going to do is we're going to move the telescope up just a little bit. Just a little. To bring in some of the other beautiful dark nebulae that will present themselves to us. Oh, yes. Okay. All right, now we're going to get our guide star. And we're going to do a 30-second shot here. We're guiding. Okay. So off we go. Into the wild black yonder. This 30-second shot is going to pull hundreds of thousands of stars into your vision. We're going to see the most beautiful, stunning sky right before your eyes. And that time is right now. Look at that. The small Sagittarius star cloud. And that is just beautiful. Dark nebulae all throughout. Is that not amazing? Most amazing, must say. Izabela. Gee, Marc, our wonderful astronomer, there's over 300 clear nights in Arizona. We don't have to see all nebulas tonight. That's funny. That's really funny. Let's see if we can get this looking better. Hey, Ian Kendall, how you doing? Ian, you finally made it. He missed it the other night and he wished he'd been here, but that's okay. You're here now. Okay, we're gonna just do this push here. And then we'll change the color correction. That's more appropriate. What I find interesting about this is that this is very, very much looking like a wet driveway. Doesn't it? Looks like a wet driveway photo. Cosmic Ray, I'm happy to tell you all that. I got my degree in astronomy in 1983 from Wesleyan University as undergraduate degree. Went to graduate school in a master's program in computer science. And then I have on my plans to actually get a master's in planetary science from Arizona State University when I get out there. So that's my plan. I've also been working in astronomy professionally for decades, and then I spent time doing computer programming things as well, and I gave that up because it just didn't suit me. So I started my own business, and I opened a visual effects company for film and television, and now that allows me to do a lot of work for the Navy, and it also gives me the flexibility to go all over the country and the world actually and do talks in astronomy, advanced propulsion concepts, and so forth. So that is something that is been on my bucket list to do, and that is all less important than creating and running these observatories. So I'm the director of 2 observatories. I'm the director of this one here, which is Skytra Livestream in Arizona, and I'm the director of Skytra Livestream here in Connecticut as well. So we have Skytra Livestream West, Skytra Livestream East. We have Skytra Radio, which is on iHeartRadio, KGRA, and various other locations on Sunday nights from 6 to 8 p.m. So we actually have a lot of astronomy things. That's an astronomy show for 2 straight hours, which is a lot of fun, and we love it. And Daryl's on that with me, as well as Amanda Curran and Tara Diulis, who was here earlier. So I think that it's so that's, there you go, in a nutshell. I also I've been talking to and work with a lot of people in the professional astronomy arena. I worked with, but I actually I do a lot of television shows as well, as a voice of reason in astronomy via the Hunt for Extraterrestrial Life. The current show that I'm on, most episodes is called The Proof Is Out There. It's on the History Channel, but I previously done NASA's Unexplained Files, One on Earth, and 100 other shows for various networks. But again, it comes down to just being the right mindset, and so I do believe that alien life exists, and I do believe that it could have found us, because the techniques they could have found us using were the basis of my lectures. I just finished doing a circuit around the country talking about Roswell, Denver, So, so that's a whole nother aspect of it as well. And I dare say I've converted some people that were kind of hardcore anti-life elsewhere people to at least be open about it. Very important. And when you look at an image like this, small Sagittarius star cloud, and you see all these beautiful dark nebulae in here, you just look at this and say, how can we be alone? Yeah. Yeah, C&D boy, you say that. You know, he says, I'm on TV in Canada almost every night. I don't know what it is about Canada, you know? But that's cool. But I'm really just trying to be a voice of reason, okay? You know, people just leap to conclusions, and sometimes those conclusions can get them in trouble, and they just have to slow down, take it easy, you know? Because they say things that they can't prove, and when you say things you can't prove, you're opening yourself up for attack. You know, you're opening yourself up for problems later. You know? Okay. This is really hard for me to do, but I have to stop this. I'm going to pause this. Sagittarius star cloud. I'm going to save it. And then I'm going to save it exactly as seen. Whew, wow. And we're gonna come out like this. There we go. All right. Now we can actually look at this nebula here. Look at that. Look how detailed that is. Wow. Amazing. Well, folks, it's 3:30 a.m. here, and time for me to get some sleep. I actually do have to get up tomorrow and work in my visual effects shop. So, well, it is tomorrow already. But I did want to just let you know that I had to just do one more, and that was it. I had to do it. So we did a bunch of really cool things tonight. So I hope you really enjoyed this. And I'm really hoping that you'll come back next time and hang with us. I think it's been a good night. We've had a lot of really cool people that came in and saw everything we did. I look forward to speaking with you guys again and hanging with you all over again. All right. So you guys have a good night. I'm gonna call it quits for now, and I'll button up the telescope, put her away, and lock the door from 2,500 miles away. Alright guys, I'll see you later. Thank you so much for coming. It's been my pleasure to spend time with you, and I will see you again very soon. Bye bye.